So hello everybody, स्वागत है आप सभी लोगों का. Welcome to the channel BYJU'S Exam Prep, the most comprehensive preparation app YouTube channel. So I hope you all are doing super fine, and as you can see, I have surprise for you all as I have promised you, right? So we will start the session, but first let's have some chit chat and then begin the session. So
Okay, so guys, let me again tell you that those who have not started SOM marathon, I have taken SOM part 1 in the morning. You can see that session later on. And we all, whether I will be taking or Joshi sir or Rohan sir will be taking, will be sharing the session in Telegram as well. Okay, so today was SOM 1 in the morning, and now it's FM 1 in the evening. Same timing, 10:30 AM tomorrow will be SOM 2. And 5 PM FM2 tomorrow. So
right.
Tomorrow will be SOM2 and FM2. Morning SOM2 I will be taking, then FM2 Joshi sir will be taking, and on 5th of January Rohan sir will be taking at I guess 10:30 or 10 AM.
10 a.m.
10 AM sir will be taking the marathon of RCC.
yes,
No, steel.
Steel and Minty is also there tomorrow. Don't forget about Minty. कल तो जंग होनी है सर.
Yes. And guys, before Joshi sir will be taking the session, let me tell you that I will be again coming today at 9 PM on Hindi channel. Okay, so 9 PM I will be coming Hindi channel with Chandan sir. Okay, telling you all the secret of MCQ, MSQ and NAT. 9 PM Hindi channel, guys. Please subscribe that, because we will be taking MSQ question. There is no book available for MSQ right now. So we will be telling you MSQ questions of each and every subject. They are on Hindi channel 9 PM today. We will be all waiting, and soon I will be sharing the link on the chat box as well.
Right.
And MSQ series will be this schedule. Although at 9 PM I will be telling you again, the classes will be 8:15 PM. When you will be no classes here, then we will be having 8:15 PM will be the class. Okay.
Right, every day.
So guys, now Joshi sir will be taking the session, and before
And
that,
do not
Rohan sir.
forget, guys, these sessions are very important. Do not forget to attend this very sincerely. Okay, each and every subject is being covered in this Maha Marathon series, MSQ series. And if you haven't prepared at all up till now, or if you are having just a little idea of your subject, you have studied lightly in your BTech, whatever may be the case, whether you are in the 3rd year or the 4th year, whatever type of student you are, do not forget to attend all the sessions very sincerely, because it is going to boost your scores no matter at what place you are at right now. Because we are going to be covering all the important questions and all the important topics in this series. And most expectedly, those questions are going to be asked in the GATE examination also, and that's why it is very, very important, and that's why we demand your sincerity.
Guys, come on here, like and share the session. This FM will be going to be very, very useful at the last time. Okay, and this will be, guys, covering all the topics.
Right.
Covering all the topics. FM1 today and later on FM2 tomorrow. And not only these, guys, the short notes also that I will be teaching or Joshi sir will be teaching, you will be getting. The PDF will be shared in the Telegram. So please share the session. And just one question, Rohan sir, from you, that many questions, many students are asking to me in the morning, and Joshi sir also, that at last time the syllabus is not 100% complete. Might be somebody is having 20% left, 30%. Then what are your suggestions for them?
If your syllabus is not completed at the last moment, my all suggestion is that if you have completed 80% of the syllabus, right, then go and make it perfect. Do not leave even a single bit of doubt in those concepts. Make sure that whatever you have already covered is up to the mark, and you do not leave even a single marks in the GATE examination from those topics, and that itself is going to help you a lot.
Okay guys, so carry on. Me and Rohan sir will again join you after some time. Till then, have blast, guys. Thank you.
Thank you, everyone.
All right. So stage is all ours now. Fluid mechanics, finally we are here with fluid mechanics. फटाफट से full power के साथ like and share the session, and let everybody know that we are live with the fluid mechanics part 1 for you all. We are going to discuss each and every concept from fluid mechanics. No, not even a single concept I am going to leave. Okay, so how are you all? Please let me know in the comment box. First, just send me a lots of heart signs, because finally we are here with the smart board. You, me, our smart board, and the notes that you will be getting from my side of the fluid mechanics in the Civil by Ninja Sir Telegram group, right? And morning Abhinav sir have took the class, So its PDF will be available in his channel, that is Civil by Abhinav sir, and similarly Rohan sir will be taking, so it will be available in his Telegram channel also. Okay guys, so everybody come on, full power. Where's the Josh? Come on, chaliye. So let's begin the session with full power. Let me first introduce myself to those who are watching me for the first time. Is there anyone who is watching me for the first time? कौन है भाई? कौन है जो नहीं जानता? चलो, so my name is Joshit Singh and I have 4 years of teaching experience, MTech from IIT Roorkee. Specialization of MTech is in hydraulic engineering, for which we all are here. All right, and get multiple times qualified, produced 20 plus top rankers AIR 100, and I want this number to go higher than this year. Okay, so will it go or not? Please let me know in the comment box. Will this number go beyond 20 plus or not this time? Please let me know in the comment box. And rest start ही करते हैं, अब बहुत हो गया बातें शाते, right? But उससे पहले let me tell you few things and then will be move ahead, right? So number of questions that you can expect in your GATE examination from fluid mechanics subjects are 3 to 6, and the marks will remain from 5 to 9, which is a lot of marks by the way. And frequently asked are the fluid dynamics. They are asking pressure and its measurement, asking laminar flow, flow through pipe. Flow through pipe is very important. What are the things that we will be covering today? So today we are going to cover everything till fluid dynamics. Okay, सब कुछ cover करेंगे till fluid dynamics. मैं जरा एक बार comments भी देख लेता हूँ भाई. I did not bring my specs. अंधा हो गया हूँ, मेरे को दिखता कम है थोड़ा सा. Very good and very excited. Superb. Me too. Super excited. So I am here all the way from Agra for this session. So that is why I am saying I am super excited for this particular session, and I hope you all are also excited for this session. So shall we begin? Shall we begin the class? By 100 watching I want. Please share. है ना? 100 watching तो बनता है कि नहीं बनता है, वाह बताओ. It should be 100, right? Fluid mechanics we are doing now. चलिए full power heart sign, let me know that we are full power ready for this fluid mechanics session, and we are going to begin from definitely not at all I am going to do this simply just I am going to tell you the formulas and that is it. Nope, I am be talking about the concept as well, because that is super duper important, and also we'll be solving the questions along with the concept so that we can have a proper understanding of all the concepts, right? Hi Teja, everybody, Sudeepa, Himanshi, and I'm really sorry I forgot to acknowledge everyone. So hi Shashi, Saltu, how are you? Shivam, how are you? Sudeepa, Sanjana, Prathamesh, Himanshi, Harita, hi, how are you? Shibi, and Tasmia, Kalidasan, Aman is here, Diksha is here, Pooja is here, Simant is here. Brilliant. I can see all the names. Pratiksha Patil, Baju student, highway class, 15th August, JNK wedding wali. Yes, I know. Itna specific, okay? You don't have to tell me. I know you. Right? Chaliye sir, so let us begin the session with full power with the very first explanation that what is actually fluid, why we are still confused. Right? We have exam on 12th February. Why we are still confused that what actually comes under fluid? Solid, liquid, gas. We are having liquid also. We are having gas also. So which one should we consider as a fluid? Anything. So should I tell this in my style? I'll tell you in my style. Anything that flows is a fluid, right? Anything which can flow is a fluid. If I just simply try to deform this remote, right? If I try to simply deform this remote, what will happen? There is a definite deformation, right? I cannot just go on and just give it an indefinite amount of deformation. No, but that doesn't happen with the fluid. If you are having a fluid, it is going to have a very indefinite amount of deformation. It doesn't matter what is the magnitude with which you are going to give the deformation. Set hai? Super easy. Clear hai? Yes. So liquids and gases, they both comes under the category of fluid because they both flows. Perfect. Grishma, hi, good afternoon. How are you? Kaise ho aap? All right, we'll talk more about it. And now whenever we are talking about the fluid, we need to understand the basic thing that there are two fluid properties. Basically, complete entire property has been divided into two categories. One are the intensive property and another one is the extensive property. Now, what is the basic difference between intensive and extensive property? For that, I'll give you a quick explanation. So, can you see there is a water in this water bottle? Say for example, right now, the volume of the water inside this water bottle is 1 liter. For example, I said 1 liter, right? Arey yaar, I can see, I think someone has started or turned on the caption. Captions are coming below my video. I have a really bad English. I'm so sorry. I feel it now. Okay, no problem. So suppose there is 1 liter water inside this water bottle, and the temperature of this water is right now 27 degree. How much? For example, 27 degree, right? I'm not thirsty, but I'm doing this for science and for you all, right? I'll drink this water. Some of it I'll drink. So, okay. Now tell me, I have reduced the amount of water which is there inside the water bottle, correct? Correct. So please tell me now, right now, what is the temperature of the water which is remaining inside this water bottle? Who will tell me in the comment box? Let's see. सबसे पहले कौन बताता है? Come on everybody, full power. The time is very less with us, and that is the basic or the very important motivation that you can ever have, because we all are engineer. We have this tendency, we have this capability, we have this ability. अपना spider sense है ये, that we can work under the last moment much efficiently in comparison to the other time that we are having. Yes, same temperature, right? Okay, so I reduce the amount, still the temperature remained same, so temperature becomes the intensive property because it does not change with the amount, correct hai? Okay, but earlier the volume was 1 liter. The volume was 1 liter, but I somehow, I don't know how, but somehow I drank 500 ml out of this 1 liter. So now after drinking the water, can you please now tell me what is going to be the volume of this bottle? What is the volume of this water inside the bottle? It will be 500 ml. Remaining water volume will be 500 ml. So volume changed, correct? Volume changed. So that is why volume is an extensive property. So that are independent of the fluid system are intensive. So it doesn't matter if you are going to change its mass or you change this amount. If the property remains same, that property is nothing but intensive. Now are you up for a very interesting fact? मस्त सा एक fact बताऊं, बोलो quickly, right? Ever if you ever get this question, you should always remember this one thing, that the ratio of, I'll just write this down. Oh my god, it feels so good to write on the smart board. I think I'm taking class after so many months on smart board, right? So the ratio of two extensive properties will give you intensive property. Super duper amazing सा fact है, but super important for your exam point of view as well. Now if you have got the feel of these properties, can I have a heart sign? And please hit the like button. Come on, hit the like button. बहुत दूर से आए आपके लिए चल के, समझ रहे हैं आप? Actually I was not in Agra, I was in Punjab. So today morning only I came to Delhi for the class. फटाफट से like करेंगे and let me know if you have a doubt here. I have a few examples also. अरे कहाँ गया example? Copy नहीं हुआ. No problem. Quickly everybody. Clear? Full power. Everyone. One example. Shivam Singh is asking. My younger brother is also. His name is also Shivam Singh. Okay. So another example of extensive. So density. What is density everybody? Density is the ratio of which two properties? Quickly tell me. चलिए शिवम आप बताइए. Density is the property of, density is the ratio of which two properties? Let me know the answer. Come on in the comment box. हो जाएगा शुरू. It is mass upon volume. If I am drinking the water out of this water bottle, the mass is getting reduced, correct, right? Mass is getting reduced. Volume is getting reduced. Yes, volume is getting reduced. But did it change the density of the water? Please tell me. Did I change the density before and after drinking water? Obviously no, right? So density is a intensive property, whereas mass and volume, they are the extensive properties. Is it superpower clear everybody? Have a doubt? Please ask. I'm here only for you all. And not only for technical doubts, if you have any general doubt that you want to ask, please ask, right? Please ask. I'm insisting. Clear hai? Set hai? Full power. Everybody, chale aage. Chaliye sir. Let's move ahead. Okay, now the very basic thing, but they are basically the soul, right? They are basically the soul of the fluid mechanics, right? You need to know these properties. If you have any doubt in this, we are going to clear them right away. Cool. The first thing is the density. There are two things that we need to all right now differentiate, and that is the mass density and the weight density. We have to be very clear about this mass density and the weight density. When I say mass density, that simply suggests the ratio of mass upon volume, and because we take water as our reference if we are dealing with liquids, and if we are dealing with gas, then we consider air as the reference, right? So that is why we need to know the density of the water will be 1000 kg per meter cube, or 1 kg per liter, or 1 gram per cc, right? Any one of these things that you can remember. Okay, but this is super important. You need to remember this. Cool. Okay. Now if you have anyone have doubt between mass and weight, please let me know. If anyone have a doubt, please don't just stop sharing the session. I would be super happy to see more people here, so that I also get that motivation to keep going and tell you each and every bit of fluid mechanics. Correct? I need classroom PDF. Yes, you will get the classroom PDF, and you will get it in Civil by Ninja Sir Telegram channel. So should I give you the link? Please tell me. No problem, I'll give you. Wait. Akash, hi. Thank you so much, and happy new year to each one of you. I hope you got my wishes also. I sent the wishes. I hope you got them, right? हाँ, मैंने लिंक डाला है. You can join this Civil by Ninja Sir Telegram group where you can find the PDF, right? And you can also ask whatever you want to ask, right? So now comes the weight density. In simply weight density, there is no mass. There is basically weight. Weight, always remember, it is a force, right? Weight is a force. Always remember that. Mass is a mass. उसको कुछ नहीं करना हमने को. Now comes the specific gravity. Now if I want to know that this particular cell phone, how much dense it is in comparison to water. Why water? Easy to remember. 1000, simple number, or 1 gram per cc if you want to take, right? Or how much dense this marker is in comparison to water. Or you tell me how dense, how many times the mercury is denser than water. Please tell me, everybody. Let's see how many of you know this or not. Super important. Why? Exam is very near. Okay, quickly tell me. How many times? Everybody. Let's see who gave the first answer. आ जाओ. Come on. Arey, for the first time I'm seeing this. Yes, 13.63. Amazing. This is what this specific gravity is doing for you, right? This is what the specific gravity is doing for you. So specific gravity is basically nothing but it is the density of the fluid. कहाँ गया? Specific gravity, right? So it is going to help you like that. So for example, I have written here also density of mercury is how much? 13.6 times of water, right? So you have to take something standard fluid, right? So if we are dealing with something liquid, because mercury, although it is a metal, as you all know, but at room temperature it is a liquid only, correct? So for liquid I'll be considering water, but for gases I'll be considering the air. Please remember that, do not forget about it. Then comes viscosity. What is viscosity, everybody? For viscosity, let's do one thing. Let's understand this Newton's law of viscosity. I have a very beautiful example for this. Please tell me, are you up for that example? It will take me around 2 minutes to explain you, but it is my promise that you are not going to forget it anytime sooner. Or maybe it will be there with you 2-3 years down the line, right? Quickly tell me, everyone. Hi Shruti, how are you? Good evening. Swagat hai aapka. And everyone else, welcome. Bhai, watching is 100, like 87. What is this? Make them equal, please. Make them equal. Okay, now let's understand this with a beautiful example, and that example is going to help you out to remember the things. Even if you are trying to forget it, then also you are not going to forget, right? So let's understand this. We all were there in the college, right? And we always used to get the assignments that we used to copy, right? So what happens, it is a story of few friends, right? So there is a friend, let me tell you, let me just get a page here. भाई खाली पेज दे दो हमको, ऊपर से आता है ना यार, ये अभिनव सर कर लेते हैं ऊपर से ऐसा कुछ, तो छोड़ो, I'll just tell you here only, right? So what happens, there is a normal school, right, or a college and a class, and teacher has given the assignment, right, and the assignment is supposed to be submitted in the first lecture, right, first lecture mein, but there is a student whose name is A, right, A is me, right, who did not completed the assignment. Now what is happening? Please tell me if this has ever happened with you. Okay, please let me know, right, in the comment box. So A is going to his friend B, and he tells the B that, yaar, what, you know what, I did not complete my assignment, so let's do one thing, you give me your assignment, okay, you give me your assignment, and I will copy from that, and we both will submit it tomorrow in the first lecture. Does it ever happen with you? Quickly tell me. Quickly tell me, does it ever happen with you? So A comes to his best friend B that, please give me your assignment, I'm going to copy it, and we both will submit in the next day first lecture. Now B says to A, see, we are friends, that is why I can give you my assignment and I allow you to copy it, but I cannot wait till tomorrow morning. What I can do is, I can wait till the last lecture. A was like, okay, no problem, don't wait till tomorrow, wait till the last lecture. Okay, no problem. Now what happens? B goes to his friend whose name is C. And B says to C, you know what, I have a friend whose name is A and he did not complete the assignment, so because of A, I am submitting my assignment in the last lecture. So since we are friend, you also don't submit your assignment, you also submit your assignment with me in the last lecture. Okay, no problem. But C said, see, you are my friend, okay, but I don't know who is A. Correct? So I can wait till the lunch time. I cannot wait till the last lecture. B was like, okay, no problem, wait till the lunch time. No problem. Now C goes to his best friend D and he tells that D, yaar dekho, there is a friend of mine whose name is B. His friend whose name is A did not bring the assignment, so he is submitting the assignment in the last lecture, but I am submitting in the lunch time, so you also don't submit, you also submit it in the lunch time. D says, I don't care who is A, who is B, I don't care, I am going to submit it in the first lecture. Did you notice something that happened from here to here? Everyone, please let me know in the comment box. Real life example, please tell me. Real life example, please tell me, everyone. Full power. Did you see what happened here? As we went from A to D, there is a reduction in the friendship. Correct? Am I correct? Yes or no? Did you felt it or not? Right. Now what is going to happen? Now understand. Let's bring this whole thing in fluid mechanics, right? Chalo. खेल खिलाना हो गया बहुत. Let's talk about fluid mechanics now. See what is going to happen. I have a table right now in front of me. I take the water and I spill the water on this particular table, right? As soon as I do this, what is going to happen? The water is going to flow on this table. But remember that water always flows in layers, right? There are layers of the water. For example, if this is the table, so the water is going to flow in layers like this. So definitely there will be the bottom layer who is going to come in contact with the table, correct or not? Definitely it is going to happen. The bottom layer is going to come in contact with the table and they fall in love. The bottom layer and the table are now in love. Wherever the table will go, the bottom layer will go. If the table is stationary, the bottom layer is stationary. If the table is moving with u velocity, the bottom layer will also move with the u velocity. Now nothing can happen. They are in love. This is how love feels like. Right? Okay. Now the similar concept of ABCD I am going to bring here. Please understand. As soon as I am going to spill the water on this table, what is going to happen? The bottom layer is going to come at rest, correct? Because they are in love. Why they are in love? I'll tell you, right? But they are in love. Now, as soon as this first layer will come at rest, this layer will ask the upper layer, see, we are friends, right? I am at rest. I want you to be at rest. Please. The upper layer will say, understand one thing. Since we are friends, I can slow down, but I cannot come at rest. And the bottom layer is like, okay, no problem, right? Now, this layer will say to the upper layer, see, my bottom layer na, it is at rest and it was telling me also to come at rest. But what I did, I slowed down. So you do one thing na, you also come at my velocity. But that layer will say, no, I can slow down, but I cannot come at your velocity. And it was okay, no problem. It slowed down, but did not come at the same velocity. And the same thing continues, same thing continues, same thing continues. And this is how you are going to get this variation of the velocity. Did you get this, everyone? We'll talk more about it. But did you get this, how it is coming? There it was friendship, here it was shear stress. Are you getting? There it was friendship, here it was shear stress. They both work similarly, right? And the love that we were talking about, it was nothing but it is also called as no slip condition. It is also called as no slip condition. Why it is happening? It is happening because of the multiple things. The very first thing is the friction between the bottom layer and the table, and also because of the intermolecular attraction between these two things. If it is super power clear, send me a heart sign, and then we'll be talking about the Newton's law of viscosity, which actually explains this whole thing. Newton said that the shear stress, right now, whatever the shear stress we are seeing, suppose, if I just simply rub my hand like this, definitely there is a shear stress between these two hands, yes or no? When we are cutting our hair, what is happening? When you go to the barber, what is happening? Tell me. Sir, what if velocity is same for all layers? Then that is the ideal fluid, where there is a no shear stress. It is only possible if there is no shear stress between them. Okay? Then that is the case of your ideal fluid. And ideal fluid is exactly how? Ideal fluid is exactly like the feelings that your crush is having in her heart for you. Does not exist. Okay? Thank you so much. Love you too. जो भी थे, मुझे थोड़ा कम दिख रहा है. I'm sorry. I can read the comment. नाम थोड़ा मुझे छोटा दिख रहा है. ठीक है? Okay, no problem. Now understand. What does this Newton boy said? Oh my God, this notorious kid. नहीं समझ आया भाई. What is this? Apple गिरा तो gravity. हाँ? What he did? He did this. Newton बोले, oh, gravity. I discovered. अरे भाई, you should have done something else. Okay, no problem. Understand, please. Full respect. Understand. Now, the Newton said that the shear stress is actually directly proportional to the velocity gradient, and that is du by dy. One interesting fact, if you know it, superb. If you don't, I'll tell you. Du by dy, it's okay, whatever it is. Always remember, if any property, if any element, if anything is changing in entire engineering with respect to space coordinates x, y, z, that is called as gradient. Since velocity is changing with respect to dy, it is called as velocity gradient. What about change in pressure with respect to change in x coordinate? What I'm going to call it? Pressure gradient. Okay, that's a general knowledge, nothing else. If something changes with respect to time, that becomes rate. Okay, that becomes rate. Okay, just general knowledge. It is not at all specific, something specific, just a general knowledge thing. Okay, perfect. Now understand. Now what is this du by dy? Arey, very simple yaar. If you have understood this, then everything is super power clear. So basically du by dy is nothing. I'll just make my own diagram because I like to make my own diagram and drink. Please see. These are the only two things which I make by myself. I don't trust to anyone. Chaliye sir. So basically what is happening here, this is the velocity distribution that I'm getting, this one. Perfect, parabola, yes, we have got, perfect, right? Okay, now understand. We have this layers like this, and also T. When I said drink, it was T actually. Alright, so let's say I am considering dy distance here. These arrow over here are representing the velocity, okay? These arrow representing the velocity. So, what is the change in velocity? Can you see from in this dy distance? This much. And let's say this is du. So, this particular slope du by dy is your velocity gradient. And this is what Newtons were trying to say, that the shear stress is directly proportional to du by dy. And as you all know, as soon as you remove the sign of proportionality, you have to bring into the picture what? A constant of proportionality, right? Right. And when I remove this proportionality sign from here, what I'm going to get? Let's see. I am going to get mu. ये वो वाला mu नहीं है, ये mu है आपका dynamic viscosity. And as you can see, I tried to show you how it looks like. Can you just see this one thing, one beautiful thing that you can actually see in this particular image, that look in this zone. You can barely see anything moving here. You can barely see anything moving, but see, as I'm going away from this plate, you can clearly see how fast or how the velocity is getting increased. Is it clear or not? It is just for fun, but yeah, this is how it looks. Sir, IIT ने फिर घपला कर दिया डेट में for admit card. अरे आ जाएगा, chill. Exam होगा ना, that is more important, don't worry. So, clear everyone? Are you enjoying the session? Please tell me in the comment box. Let me know if anything is required, please. Okay. All right. Let's move ahead. Is there anything which we were supposed to discuss till now, but we haven't? I think no. There is nothing that we had to discuss. We did not. Perfect, sir. Everyone clear? Please tell me. Perfect. There is one more thing which is called as angular deformation here that we need to understand. Please see. I'll tell you here only. Then we'll talk about dynamic viscosity with fursat. We have whole thing, we have good time, we have good amount of time, right? Please understand. So I'm just considering the same the diagram, right? I'm considering these two layers, okay? These two layers I'll be considering, okay? Just to show you a neat diagram, I'm drawing it here. यहाँ पे बनाते हैं हम लोग, right? So that we can get a full confidence and also good explanation we are required. So guys, please understand, suppose that there is this velocity, there is this layer whose velocity, this arrow is representing the velocity of this particular layer. Let's say it is u. कितना है? U. Correct? Let's say it is u. The other layer is like this, right? Okay. So suppose the time here is dt. The time here is dt. So can I get this length? What is the length, everybody? If I know u is the velocity and I know time is dt, can I know this length, everybody? Please tell me. Yes or no? Can I get it? It will be same only, this or this. It will be same. How much it is going to be? Let's see how active we are in the session. Kitna active hai? Let's see. Bolo. In dt time interval, I'm talking about in dt time interval. What is going to be the distance, this distance? Please tell me, everyone. In dt time, perfect. That is going to be u into dt. Brilliant. Simple concept, no problem. And what about this much? What about this much, the additional one? How much is this? This is simply du. This is simply what? Change in the velocity is du, time is dt. So this will be du into dt. No problem. Brilliant. Here also we have got it. Perfect. Arey, simple. This is the concept only. Correct? This much. Any doubt? Anybody? Please let me know in the comment box. कौन सा? So we have a magician in the house, everybody. Welcome.
Guys, everybody, see, I don't know, I do not know much about fluid mechanics, but one trick I know. When I was studying in my college teacher actually told me. Okay, so see, I guess most of you know, but still, if somebody know, see, this is I guess tau, and this is I guess du by dy. Huh? I'm just remembering fluid mechanics from my college, that is 2007 to 11. And for Newtonian fluid, of course, tau is directly proportional, so it is tau is equal to mu du by dy. But that is only for Newtonian fluid. And might be for other fluid, it can be power, can be n, can be some constant as well for different fluids. Hai na? Okay, so there are things like you have seen like this, okay, and then things you have seen like this. Okay, you have seen some graphs like this, n greater than 0, n is equal to 0, n less than 1, greater than 1. Now this is dilatant, this is Newtonium, that is n is C is 0 for that and n is equal to 1 for that. Newtonium, and that is pseudoplastic. Okay, then that is pseudoplastic, and then it is rheopratic, tiny, Birmingham, and this is thixotropic. Now, how to remember this, guys? Everybody, please, Sanju Salgar, everybody, please see now. It is how to remember all these things. D, do not play rugby before tennis. Okay, do not play rugby before tennis. And guys, not only this, this I have made. Similarly, you can make based on your friend, might be some of your friends you can name like this and remember the things like that. That will always help to the power of remembering power may be for larger time. See, many of engineers are taken history in the subject of civil services to crack civil services. So many dates, it is very, if you just remember the raw date without linking it with anybody, it is difficult to remember. If you link any date with your birthday, with your girlfriends, with your any of friends or your mother or father, then it is very easy to remember that, because once the Panipat battle comes, you have linked something with that, and that link will be coming to your mind very faster rather than that raw date. Okay, so that thing you can do, guys. Have you like it? Please put a heart sign, and now Rohan sir will be coming and telling you some tips for the exam.
Sir.
तो गाइस आ रहा मज़ा फिर फ्लूइड मैकेनिक्स में? बिल्कुल आना भी चाहिए, क्योंकि ये सारे जितने भी बच्चे बैठे हुए यहाँ पे सारे सिंसियर स्टूडेंट्स बैठे हैं, एंड आई होप दैट यू आर पेइंग फुल अटेंशन ओवर हियर. देखो गाइस,
Yes, Shivam.
बहुत अच्छे, बहुत अच्छे, बहुत अच्छे. और जोशी सर जो क्वेश्चंस करवा रहे हैं ना, सब अच्छे से पढ़ते जाओ, ठीक है. और सारे क्वेश्चंस वो एक्चुअली एटलीस्ट वो कॉन्सेप्ट तो अच्छे से सारे सीख के जाओ, ठीक है ना. और अगर आपने और कुछ भी नहीं पढ़ा ना फ्लूइड मैकेनिक्स में, ये बस 4 घंटे रट जाओ. एक ऐसे करो, फ्रेश पेपर लो, ठीक है. जिन्होंने कुछ भी नहीं पढ़ा अभी तक उनके लिए बोल रहा हूँ, अगर आपने पढ़ा है, अगर आपने सब्जेक्ट बिल्कुल ही नहीं देखा, बिल्कुल ही नहीं सुना, तो एक फ्रेश पेपर लो, ठीक है. और क्या करो, उसको 2 पार्ट्स में से डिवाइड कर दो, ठीक है. फ्लूइड, ठीक है. और स्टार्ट हो जाओ, एक एक पॉइंट नोट करना, ठीक है. डेफिनेशंस वगैरह कोई नहीं पूछेगा गेट में, न्यूमेरिकल्स पूछेंगे, फॉर्मूला पूछेंगे और की कॉन्सेप्ट्स पूछेंगे, ठीक है. नोट पॉइंट जो जोशी सर बोलेंगे कि बहुत इंपॉर्टेंट पॉइंट है, एक एक करके पॉइंट लिखते जाओ. फॉर्मूला आता है, लिखते जाओ, जो लिख पा रहे हो सारा लिखते जाओ. और इस तरीके से आपका ये 4 घंटे में बन जाएंगे एट मैक्स 10 पेज, बहुत ज़्यादा बोल रहा हूँ, और 10 पेज पढ़ के जाने आपको. और ये अगर ये आप 10 पेज बन गए हो, और ये 10 पेज बन के पढ़ के अगर 4 से 6 मार्क्स का अगर फ्लूइड आ गया, और उसमें से आपने 3 मार्क्स भी गेन कर लिए, 400-500 रैंक ऊपर हो गई आपकी, ठीक है ना. तो बहुत इंपॉर्टेंट है ये सारे। स्टील आ रहा हूँ परसों, सॉम चल रहा है, सारे सब्जेक्ट चल रहे हैं, ठीक है। ये ऐसे शॉर्ट नोट्स बना लो और उनको एग्जाम से पहले कितनी बार रटना है? 3 बार, 3 बार रिवाइज कर दो। एक बार आज बना लिए, एक बार रिवाइज, दूसरी बार रिवाइज, तीसरी बार रिवाइज। और गारंटी के साथ बोल रहा हूँ 45+ मार्क्स सारे होंगे, मिनिमम टू मिनिमम है, मिनिमम टू मिनिमम 45+ मार्क्स, ठीक है ना। तो इसीलिए पूरे अच्छे से, पूरा सिंसियरिटी के साथ अटेंड करने ये सारे महा मैराथन्स। या
Okay. Sir, may I tell you some more tricks?
Yes, yes.
Students. Okay. Guys, see, I'm telling you 5-6 tricks. Okay. And now you also, and Joshi sir also, and Rohan sir also has to tell that which trick they like best. Okay. Very quickly, within 3 minutes, I'll be telling you each and every trick. Now, this will be, I guess, first. This will be second. This will be third. This will be how to guess. How to guess also, there will be some tricks. 4, might be 5, might be 6. Okay, so everybody, you will take a screenshot after it, and you have to tell that out of 1, 2, 3, 4, 5, 6, which trick you like most. And Rohan sir, I will also ask, and Joshi sir also.
Right.
First one is suppose you have to in degree 61 degree minus 26 degree 32 minutes. This many times I have told, but some of the tricks will be new one also. So instead of the 61 degree na, make it like this. Instead of 61 degree, make it like 60 degree. 59 minutes and 60 seconds, because that is also 61 degree. 60 seconds is 1 minute, 59 minute and 1 minute is 60 minute, 60 minute is 1 degree, and 1 degree and 60 degree is 61 degree. So both are saying now it is very easy to subtract. Like it will be 42 seconds, it will be 42, 52, 27 minute, 36, 46, 56, 34 degree. Okay, like this. Now again, everybody, next trick. Everybody please see. This I'll tell you tomorrow. Tomorrow is Som. Som 2, morning 10 a.m. FM 2, 5. And day after tomorrow, Rohan sir will be at 10 a.m.
10 a.m.
Tomorrow, Som at 10:30. Som 2, then FM 2 evening, then Rohan sir day after tomorrow. Now this see. Everybody. Rohan sir, Joshi sir, please see. Suppose the length is L-E-I. What is deflection? Everybody know. PL3 by 3EI. Okay. So another beam, everybody. L, same material, E, but it is having larger cross section area such that it is 2i. Now P, again apply the formula, deflection of the free end is PL3 upon 3e into 2i, so it will be 6ei. This everybody knows. But suppose in exam the question comes like this. 2e, 2e. P load, let it be 0.3L, let it be 0.7L, let it be 2i, let it be I. Now it is very difficult. There is no standard formula. Now what to do? Suppose if you know strain energy method, if you know any other moment area method, you can solve it. It's well and good. But suppose you don't know, then you know that this beam is the most weakest beam, because it is I. It is strongest. So here deflection of this red one will be less than this one, because this is weakest. So deflection will be less than PL3 by 3i, and deflection will be greater than PL3 by 6ei, because this is most strongest. Like this you can eliminate the option. Another thing, guys, everybody, this is first, second, you have to tell which trick you like most, and everybody please like and share the session, guys. Now see, another trick. This trick is mostly for exams like PSU and state services. Everybody, please see. Suppose there are 120 questions, and 120 questions, 110 questions you know. Okay, so 10 questions you don't know. Now suppose out of 110 questions in which you are very, very confident, out of A, B, C and D option, least option is C. Matlab, if you have solved 110 with very high accuracy, 98%, and least option you are getting C, matlab most of the options are A, B, D. Then if you want to guess, that's on you. Then out of these 10, put all C. Most of the cases you will be getting benefited. Why? Because in 2006 and 7, Coal India Limited, see, many students which are not preparing, but they have filled the form, then parents are sending go. They are going and then putting all B, all A, all C, all D. That time, many students who put A, B, C, some of the students have put all B. And the paper was very hard. Paper was very hard means cutoff will be very less.
Low.
So cutoff will be very less. That means the students who have put all B, and interestingly 45% options were B. They are Coal India Limited, and they are still in the post. Then many people have objection that somebody has selected like this. Then what to do in court? They are yes. They see unfair means is a crime, but they are saying yes, we have tukka mara humne, we have guessed. But what is wrong in that? Nobody
Right.
can take their post. So this is 1, 2, 3. Now coming to fourth, sir, please.
Yes.
I am taking too much time of your class.
It's okay.
Now see, suppose gate. This was for PSU and state services. Let us for gate. Gate, guys, suppose out of 65 questions, 12 questions, you know that only out of 2 options, 1 is correct. Out of 2, 1 is correct. So, guys, in my opinion, click the answers. Why? Because on probability, you will getting 6 correct, 6 wrong, because 2 options you are eliminated anyhow. So, 6 right, you will be getting 6 into 2, 12. And 6 wrong, you will be getting minus 2 by 3, that is minus 4. So, plus 12 minus 4, you will be getting plus 8. So, you, in fact, guys, if you do 7 wrong and 5 right now, then also you will be in plus. Okay, so this is first trick, this is second trick, this is third trick. More tricks of deflection I will be telling you tomorrow in SOM 2. This is third trick and this is fourth trick. These 2 tricks are purely technical and these 2 tricks are purely, guys, on the basis of, guessing. There are many more tricks. Okay, I am not want to waste Joshi sir class time. Otherwise, he will be telling me afterwards that.
Take your time.
Okay, guys, now, you all have to tell which trick you like most. More tricks on SOM tomorrow. Either right answer on 1, 2, 3 or 4. 1, 2, 3 or 4. Sir, you are?
Sir, this one.
Second.
No. I like
Sir, 1, 2, 3, 4, all the tricks are awesome. All the tricks are awesome.
You also, guys, please reply. Yes, Tiksha Patil, minus also I am considering here and minus also I am considering here, both the ways. Okay, if somebody has the luck like Rahul Gandhi, then the difference maybe, the marks may be in minus also. Don Saji Chota, thank you, good buddy. Guys, please let me know which trick you like most. LKS is 1, Shivam Singh is 1, 2 is which one? Okay, 2, 1, Selvam 1. All tricks. Guys, please like the session here for the tricks. Everybody. And PDF will be shared in Telegram. 2 and 4. 2, 3 and 4. Okay, 1 you already know might be.
और एक और चीज मैं बताना चाहूँगा.
My favorite is the second one.
एक ट्रिक मैं बताना चाहूँगा.
And also this one.
बहुत ही इम्पोर्टेंट ट्रिक है. कई बार क्या होता है आपको गेट में आपको कोई क्वेश्चन आपने नहीं पढ़ा, आपने वो सब्जेक्ट नहीं पढ़ा, बिल्कुल भी आपको आइडिया नहीं, तो आप क्या किया करो ना, वो क्वेश्चन को एटलीस्ट एक बार रीड किया करो. ठीक है ना, पर्सनल एक्सपीरियंस है. मैंने अपने गेट के एग्जाम में क्या हुआ था, एक क्वेश्चन मैंने बिल्कुल भी नहीं पढ़ा था. ठीक है, पर बेसिक मैकेनिक्स, बेसिक एप्टीट्यूड तो सबको आता होता है ना. तो मैंने जब वो क्वेश्चन पढ़ा, मैंने ऐसे ही देखा कि चल ठीक है यार, समझ के देखते हैं, लेट अस सी इफ आई एम एबल टू आंसर दैट क्वेश्चन और नॉट. ओके, सो आई रेड द क्वेश्चन and based upon that question I understood a little bit about what the question is trying to ask, and based upon that I picked the option based upon my aptitude, right? And that option luckily came out to be correct. So do read each and every question at least twice. And sometimes there are certain questions in which you are asked formulas A, B, C and D. Okay, try to do the dimensional analysis of each and every formula.
Yes, in an environment it is very beneficial.
It
environment
is very, very
is
important. Okay, try to do the dimensional analysis of each and every question. See, if you do that, sometimes you are asked to find out length. It is asked what is the, let us say, whatever some length is asked to you. Okay, some length is asked to you. What is the length of that particular thing? So when you see all the dimensional analysis of all the formulas, 90% of the time you will find that other formulas are either L inverse or ML minus 1 or T minus 1. Only one option will be there, which will be L. And with that, without even knowing the answer, you will be having the correct answer to that. And do try to see whether the answers are around the, what is the expected value. So suppose if in a question deflection is asked, okay, for a beam of, let us say, 4 meter. Okay, now you must have an idea that the deflection will be in the range of either 30 mm, okay, but the option is giving you 100 mm or 190 mm, 280 mm, and one option is there of 60 mm. So you will have 60 is also very large. I will say 25 mm. So you will go with this D option, because the other options are very out of the range, right? So like this, try to analyze the question and try to know what is the appropriate value of that.
Sir, one trick na, I never told you. One trick matlab that all trick I also tell students in offline, but that same trick you are also telling. I have seen your session. that whenever, see, in beam RCC, AST will never be 30,000 mm square and will never be 20 mm square.
Yeah.
AST will be around 300 or might be maximum
1000 mm, 500 mm.
might be for extreme load 2700.
Yeah, right.
So whenever you are doing subjective questions and your AST is coming 3 lakh millimeter square or 25 millimeters, so that is wrong.
Yeah.
Similarly, in case of option, it should be around 300 to 7. If very heavy load, 500 kilonewton meter, then it can be in that range. Otherwise, it is around 300, 700, 800. So that thing also, that thing I also teach students in offline, and I was seeing one of your session might be 4 months back. I never told you.
Yes.
So the same trick you are also telling.
That is very important.
And same trick, guys, many more tricks are there that I'll be telling you tomorrow at 10:30 am from Som 2. Then Joshi sir will be coming more ninja tricks. Okay? And Joshi sir is going very far away.
Yeah.
Might be he's not liking that we are disturbing his class. Guys, are you feeling that we are disturbing your class? Or are you enjoying those tricks? That 7 to 8 tricks here. Come on. They
Come
are
on.
pure tricks.
First
Are you
of all,
enjoying?
each and every give likes. Like the session and share the session it up.
Like and send the heart sign for these amazing tricks that you all have got. Quickly, everyone.
This marathon session has been designed in such a way that you are able to get a maximum out of the gate examination even if you have not prepared at all. Okay, so again and again I am saying attend the complete session of Joshi sir. Complete session. Each and every point should be noted down in your short notes.
Okay,
Quick.
thank you Santu, Atul, Aman, Tiksha, Santu. But somebody like Sudepa is saying not, he's not liking, I guess.
He is a sincere student, very very sincere student.
But
He
these
is
all will
only-
be helping, sir. These
Yeah,
will be helping
these are
more.
very helpful to you.
These will be helping like 5 to 10%.
Read each and every question twice, guys. I'm telling you, even if you have not studied it, that topic at all, each and every question, read it at least twice. Try to understand the question.
So, just last
Gate
question.
is a aptitude examination. Mark my word.
Right.
Just last question, guys. See, most of the subjects are covered by us three: FM, highway, irrigation, environment,
OCF.
transportation, OCF.
हाँ जी.
OCF is mine also.
Right.
See, SOM, survey, hydrology, soil mechanics, open channel flow also, and PERT-CM also I used to teach. Okay, OCF also. Now RCC, steel, structural analysis, SOM, soil, most of the subjects are here, like heavy subjects. RCC, steel, SOM, structure. I think, sir, you can teach, I guess, every subject.
Every subject.
96 rank, okay, from ISC Bangalore. Now, which is your favorite subject? My favorite is two, SOM and highway. Sir, yours?
RCC and steel.
See, and yours,
Sir,
let me guess, FM and highway.
FM highway.
And what is your favorite subject? What are your favorite
Go
subjects,
on.
guys? And everybody, please like and share. Let more people join in. More commandos can join in. Marathon is going on, guys. And let me tell you that we are. See, right now in SOM session I have taken from my home. Now I am in office. Okay, and from tomorrow on, me, Joshi sir, Rohan sir will be taking class from my home only. Every faculty is here, not us only we, civil people here. The same guys like electronics and mechanical, computer science are also here. Okay, so everybody is for you guys. Highway, geotech, my god. Usually I find SOM more people, but SOM here is less. OCF and survey. Usually, see guys, not like because I like
Highway.
SOM, but SOM is the backbone of civil engineering. Because RCC is SOM.
Definitely.
SOM is
definitely.
backbone. SOM is just the key to unlock many subjects. Structure will be open from SOM. Okay, RCC SOM will be required. Steel SOM will be required. Soil, shear strength chapter, SOM is required. Okay.
Strength
So,
of material is like
my subject
mechanics
is-
to engineering.
Right. And when it will come to your favorite subject, highway is the favorite subject. Okay. Always tell everyone highway is favorite. Alright, ठीक है. So must be, it is utilized in a lot of subjects also, but ठीक है, highway is the best. You can see everything. Everything is there in front of you. You can see camber, you can see curve, you can see everything. You can see the extra widening
I
also.
can see a lot of RCC as well.
Well, sir, hardly I can sir see anyone.
Sir, please
नहीं but
continue.
still.
Okay, sir.
Still.
Thank
चलिए, thank you, sir.
Thank you for your time.
Come soon.
Marks for free.
चलिए. So let's continue with the things that we were discussing. But yes, if you want, you can take the screenshot also with these amazing tricks that sir have told. Please quickly take the screenshot. You have 5 seconds. So 5, 4, 3, 2, 1. Time is up. No problem. You can also go, rewind the video and then again take the screenshots. Come on, let's come back to this. We're talking about something called as the angular deformation, right or not? Yes, so let's talk about this. So we were here, u dt is this much distance, du dt is this much distance, right? And if I make this here and this angle is d theta. Now you are going to tell me, guys, what is going to be the tan d theta? Quickly please tell me tan d theta. Everybody in the comment box, if I want to know what is tan d theta, what is going to be the value? Tan d theta. Come on everybody, full power. Chaliye. Everyone in the comment box right now, and after this we'll be discussing about the variation of the viscosity with the temperature, which is also very important, right? Yes, it will be du dt by what? This dy. इसको मैंने नाम नहीं दिया, कोई बात नहीं, हर प्यार का नाम हो जरूरी नहीं है, right? कुछ there should be some things, right? इस प्यार को क्या नाम दे वाला? So this is that only. Cool, sir. So this FM, it will be covering till fluid dynamics. We'll be covering till fluid dynamics, and tomorrow we'll be covering other important subjects, another important chapters like flow through pipe. That is very important. Dimensional analysis we'll be discussing. We'll be discussing very deeply the model analysis, the model's law, which is very, very important, right? Because that is being asked very frequently, especially the Froude's model law. Froude's model law is being asked very frequently, right? So we'll be working on that as well. Okay. Yes, OCF will be there also, don't worry. OCF will also be there. We are here to take the class for all the subjects, don't worry, right? So from here, as you can say, this theta angle is very small, so tan d theta is nothing but is equals to d theta only. So from here you can say d theta is equals to du dt by dy, and here d theta by dt is equals to du by dy. So angular deformation is nothing but it is equals to the velocity gradient, and this is what we were trying to understand. So next time, if in the question you get, instead of du by dy, you get something known as, or something you see like d theta by dt, don't think that it is something that you haven't studied. You know it, right? It is nothing but it is equals to du by dy. So if you have got this, please let me know in the comment box with a heart sign. If you have a doubt, you can ask the doubt also. Kinematic viscosity, dynamic viscosity units, they are super simple. I don't think we have to discuss the units, right? That is very simple, but you need to know them, right? What you need to know them is this thing, the Stokes and the Poisson system. Stokes and Poisson, these two things are very important in the examination. Most of the time what will happen, they may ask you, or they may give you the information in terms of Poisson or in terms of Stokes, and they will not even let you know directly. They won't tell you that it is a dynamic viscosity or it is a kinematic viscosity, but you can clearly see if they say Poisson, suppose 10 Poisson they are giving to you, so you have to convert this 10 Poisson into CGS, and that is nothing but just multiply it by 0.1 or divided by 10. That is the same thing, correct? So that is nothing but your dynamic viscosity. But in case they give you something in terms of Stokes, so that is nothing but just multiply or divide it by 10 raised to the power 4 or multiply it by 10 raised to the power minus 4. You will get the CGS unit. It is super important. Okay, so everybody, please tell me. So sorry to interrupt. Impact of jet, weird notches are necessary to study. No, impact of jet is not in your syllabus, by the way. You don't have to study those things. Okay, let's do this beautiful question. I have a question for you. Let's see who gives the first answer. Everyone, let's see this. A plate whose area is 2 meters square, on which fluid flow with velocity profile u is equals to 2y square by 7 minus y by 5, where y in meter is distance from plate and u in meter per second. Calculate shear stress in Newton per meter square at y is equals to 0.4 meter from the plate when the flow is laminar. So basically what we are having velocity u as 2y square by 7 minus y by 5. Come on everybody, let's see who gets the first answer quickly in the comment box right now. चलिए हो जाइए शुरू, फटाफट से आंसर आएगा. So the thing that we are going to need is, we want what? We want shear stress ना, ठीक है. It's a super simple question, but ठीक है, we'll do this. So tau is equals to what? Mu du by dy. All I need is this du by dy first, because everything else is given to me. Is it given to me? Yes. Come on, find it out. Chaliye, calculate the shear stress, everybody in the comment box. Let's see who get the first answer. Let's see who get the first answer. Come on. Quickly. हाँ जी. So first we need to get the du by dy. So how much is going to be the du by dy value? It will be 4y by 7 minus 1 by 5, right? But I need it at y is equals to 0.4 meter. Right, I'll be putting the value of y as 0.4 meter, and mu you can consider as mu you can take it as 0.015, right? Yeah, 0.015, and with the help of this you will get the value of tau. And now something very very important that you need to understand in the examination also, when there will be a NET question, or if there is any MSQ question, then also you need to understand, we need to see in which unit they are asking the question. That is very very important. ठीक है, देख लेना किस यूनिट में पूछा गया है, otherwise you can make a blunder mistake. Even if you know the concept, still after solving all those things you may get the wrong answer. ठीक है, just because we did not study or we did not read the question properly, right? So the question, the answer to this question you must be getting is this A option. ठीक है, you can just solve it. The answer should be A. Anyone got the answer or not? Please let me know in the comment box. A, brilliant. See, lot of you have got this. Amazing, badhiya, full power. Okay, now the causes of viscosity. There are basically two causes why the viscosity here is happening is intermolecular force of cohesion and molecular momentum exchange, MME, and intermolecular force. Now please understand everybody, ये जो दोनों चीजें है ना, they are also actually very significant related to whether it is more predominant in liquids or it is more predominant in case of gases, right? So when I say intermolecular cohesion, so what is cohesion, by the way, everybody? What is cohesion? Quickly tell me. Cohesion is getting married in same caste, basically, right? Same caste, it is cohesion. But intercaste, it is adhesion, right? So adhesion is basically the attraction, the force of attraction between the particles of two different substances, okay? Whereas cohesion is the force of attraction between two particles of same substances, okay? That is cohesion and adhesion. So here one of the reason for the viscosity is going to be your cohesion, and the other is molecular momentum exchange. Please always remember this is more predominant in terms in cases of liquids, and this is more predominant in terms of or in cases of gases. Very important, please remember this, and that is the only reason why that viscosity of the liquids getting reduced when we increase the temperature. When you increase the temperature, what happens? Please tell me everybody. When you heat up, when you are angry, what happens with your relationships? What happens with your, whatever the relation you are having with any of your friend or maybe girlfriend or maybe boyfriend? They start getting, that bond starts getting reduced when you fight, right? Similar thing happen here. When you increase the temperature, the same thing is going to happen. Just opposite of this happens when you are talking about the gases. In gases, as the temperature increases, this exchange, molecular momentum exchange, it rapidly increased, right? Because of the excitement, because of the increase in temperature, and that actually increases the viscosity in the gases, okay? So as the temperature will increase, there will be a decrease in viscosity in your liquids, whereas increase in the viscosity in terms of gases. Is it superpower clear? Can I have a heart sign in the comment box, please, if it is clear? Anyone have any doubt? Please tell me. The next thing that we are here to talk about is the surface tension. Now what is surface tension? Surface tension is a very simple concept. Yes, there is a tension on the surface. There are two type of property when we are talking in terms of a liquid here. There is a mass, or you can say bulk property, right? Or surface property. For example, boiling. Boiling is a surface property or a bulk property. Who will tell me? Come on. Boiling is a bulk property or it is a surface property? Let me know in the comment box, please, everyone. 90% data exhausted. I'm really sorry, but I'm trying not to waste your even a single second. Yes, correct. Please answer everyone. हाँ जी. So bulk में आपका boiling is going to be the bulk property, whereas evaporation is a surface property, correct? Correct. They both act differently. Like the bulk properties are completely different from the surface properties, and here the surface tension is also obviously in the name we are having, it is surface, right? So it is predominant here on the surface only. Now how this tension is coming, so please understand there is a cohesion force between the particles of the liquid. Correct. Let me just show you with the help of a beaker. I'll make a beaker over here, right? Suppose it is filled till up to this level. Let's say, for example, it's water, right? Okay. Now let's suppose here we are having a particle. Now can you please tell me what is going to be the net force on this particle right now if all the particles which are surrounding this particular particle are attracting, or they all are attracting them towards each other? So what is going to be the net force on this particular particle? Quickly tell me. Simple. Zero, right? There will be nothing. So this particle, will it move from its position? It won't. It will remain where it is, right? But if I talk about the particle on the surface right here, it is going to have the attraction from this side. Yes. It is going to have attraction from this side. Yes. It will have it from this side. Yes. This side. Yes. This side. Yes. But it has nothing from the upper side. So can you please tell me what is going to be the net? Can you please tell me the net force here? Or you can tell me, will it move? Or if yes, then in which direction? Definitely. All the left and right side component will be cancelled out, and this whole particle will have movement in the downward direction. Yes or no? Super simple to understand. And that is the only reason why on the surface the particles are more closer to each other. That is the only reason why the particles are more closer to each other on the surface. And since the particles in the lesser volume, more particles are there, that simply tells us that there is a more cohesion force in the very, very small volume. And that actually gives us the surface tension, because the particles are pulling each other, or you can say they are trying to attract each other towards one another's. Any doubt, anyone? That is why we get this surface tension. Now, beautiful story of chocolate. I have given you the example. Yes or no? Chocolate example. You know this, right? Everyone. There is one more thing which is called as surface energy. Do you know that there is an energy on the surface? Do you know this? See what happens when this particle, it comes down. Obviously it has to come down. It has to come down because the net force is going in the downward direction. What has happened? As soon as it will come down, there is another particle who is going to take its position. And when this other particle will take its position, it will also come down. Then another particle will take its position. Then that another particle will also come down. And some other particle will take its position. To do this process continuously, there is a proper energy on the surface, and that energy is called as the surface energy. And my friend, let me tell you something very important, guys, ki there is a chocolate factory. There is a chocolate factory in China who used to manufacture chocolate bars. Wala bar nahi, chocolate bar, right? They used to export the chocolate bars from to other countries as well, right? But they used to get complaint from the countries which used to be very far from China that as soon as we get your chocolates, they are either in very, very deformed shape, or they are completely melted. So now that factory is having only two options left. One, either they stop the exporting, or they make their own manufacturing plant in those countries. Right, sir? Right. But the R&D department of that chocolate factory came out with another beautiful, very, very beautiful solution. Please tell me, melting is a bulk phenomena or it is a surface phenomena? Please tell me, everyone. Intermolecular. Intermolecular is nothing. It is basically something between two molecules. Interfaculty means there is something between the faculties. Inter-school means something between the schools, right? Tell me, everybody. It is obviously surface, right? When the ice cream is getting melted, it always melts from the surface. Then we simply lick it. Simple, right? That's the solution that you do, right? Simple. So the melting was the surface phenomena. So the problem is with the surface. Can you tell me the geometrical shape which is having the least surface area? Spherical, spherical, right? मन में लड्डू फूटा, 2 रुपए में 2 लड्डू, right? And that's how that chocolate balls came into the picture, because they have the least surface area, and since the surface area is least, the melting is least, and now the chocolate can be sent to farther countries also. And similarly, let's come back to the fluid mechanics concept. Since we know that there is a energy on the surface, correct? Yes, there is energy on surface, but the thing is, you, me, everyone wants to, settle. We always wants to, get stable life. When you have lot of energy, are you going to get stable life? Or when you are calm, everything goes smooth, things are working out, your crush said yes, that time you are going to be more stable. I'll say the other way around. Correct? Correct. When the energy will be less, I'll be more stable, you will be more stable, correct? Surface will be more stable. And that is the only reason why the surface is trying to take the shape of a sphere. And that is why the water droplet is always spherical, not any other geometrical shape. Right? You might say, no, it is not spherical, sir, it is like this. Yes, because it also has the factor of its self-weight. Right? That is why it is like this. Is it clear, everyone? Can I have a heart sign? Will you remember this for me? Please tell me. Just say it yes. Say it yes. We will always remember it. We'll never forget. Clear, sir? Everybody, every champion. Is it clear? Perfect. Amazing. Great. Okay. Now, if I just want to tell you in mathematical terms what is surface tension, that is very simple. Like if I show you the surface of this vessel only, this surface only, let me tell you. So it will look like this. The surface will look like this, right? If I take a unit length over here, let's take it here, this much, right? Let's say this length is L. Right, this length is L. Now you all know, guys, you all know that particles which are here, you can say the left side and the right side. The particles which are on the left side, they will try to attract the particle from the right side in this direction. Similar thing will happen to the other side. So let's say that the net force that they all are putting all together is F. So the surface tension is basically this force per unit length, this length, okay? That is your surface tension. Clear, sir? Newton per meter. Newton per meter or joule per meter square. Whatever you feel like is correct. Whatever you feel like is perfect for you, you can use it. All the Gyana I have written over here, this is a PDF which is going to help you out in understanding each and everything, because I have kept the theoretical part for you. Whatever I am speaking, whatever I am saying, it is already written over here. It is not just a PPT I am using to teach you, but it is actually a chalta firta PDF of the notes for you all, because I knew it that eventually I have to give it to you. Right. The next thing comes out to be what is going to be the pressure difference inside and the outside of different elements, in which the number one is the water droplet. So suppose if I have a water droplet whose radius is R, this is a water droplet, right, and its radius is R. Can you please tell me, everyone, let's say P, pressure inside is P in, pressure outside is PO. Can you tell me who is greater, P in or PO? PI or PO, who is greater? Quickly answer, everyone, right now. Always remember one thing in your life, ever, never forget this. Momentum exchange means, see, there is what happens when you talk about gases, right? There will be different lumps. So the molecules of this particular air or any gas, they are basically, what they are doing is they are transferring from one, you can say, one set of molecules to the other set, right? So when they do this, they also exchange the momentum, right? So now what happens when we increase the temperature, this process actually increases. Now there is a more amount of momentum transfer, and that actually increases the viscosity of the gases, right? Okay, those who are confused between PO and PI, always remember in your entire life, do not forget this, that the pressure which is there towards the concave side is always greater. Always greater. Let's take a balloon. This is the balloon, right? So here the pressure will always be greater than the pressure here, right? And this is the concave side. Just remember this thumb rule, never forget it. If you ever get confused, remember this concept. Okay, now let's come back to the thing that we were discussing, and that is what is the difference between PO and PI. And that is simply, let me tell you, please note this down. Doesn't matter if you know the whole concept or not, if the question will come, you will be able to answer this, right? So yes, P gauge, basically I'm trying to get the difference between the pressure inside and pressure outside. Since we know the pressure outside is atmospheric pressure, definitely any pressure which is greater than the atmospheric pressure is called as gauge pressure. I'll come to that, don't worry, I'll come to that. I know there are a lot of confusions over there. Can you tell me who among you are having confusion between the absolute pressure, gauge pressure, vacuum pressure, negative gauge pressure? Let me know in the comment box how many of you are getting confused there. And if you take the soap bubble, it is just double of this. And please remember, everybody, if suppose you get a different case in which you are having a air bubble inside water, can you tell me out of these two, let's say this is number 1 and this is number 2, which formula will be applicable? If I'm having a air bubble inside the water, we can have air bubble inside the water, correct? Please tell me out of 1 and 2 which is going to help me out. Let's see. Come on, everybody. Don't worry. Those who have doubt, trust me, after this class, you will never get confused. Okay? You will never get confused there. It is my promise. It is my, you can say, confidence that I'm giving you. Don't worry. Definitely. Okay? So guys, if you are having a air bubble inside the water, then the thing remains same. This only. 2 sigma by R. Nothing will change. Okay? Nothing will change. Yes, Prathamesh, income concept I'll be telling you for to remember that particular concept of the gauge pressure, absolute pressure and the negative pressure, right? Or vacuum pressure. And in case of a jet, the sigma by R, simple concept. I'm not wasting time of yours here only. Okay, very important concept, wetting and non-wetting. Wetting and non-wetting concept. Let's try to understand wetting and non-wetting concept. Everybody, it is a kind request. Please share the session with your friends. I can see people are getting lesser. And also, I'll quickly tell you the link of my Telegram group so that more people can join it for the PDF, because PDF are very, very important. Let me just give you the link. Haan bhai, are you enjoying it or not? Please tell me. Fluid mechanics. I'll show you the experiments also. Tomorrow, I'll show you the experiment of lot of things like Magnus effect. You want to see the experiment of Magnus effect? We'll see that experiment of the Magnus effect, okay? In the tomorrow's class, because we are going to cover that in tomorrow's class at 5 p.m. right? Okay, everyone. Now, wetting and non-wetting fluids are very important. Understand, everybody, there is this something called contact angle. So, I have two things in front of me, water and mercury. When I put water and mercury on this particular glass, what I see that the water is taking the shape like this, whereas mercury is taking the shape like this, right? Mercury is taking the shape like this. Always remember, wetting fluids are having more adhesion than cohesion, whereas non-wetting are having more cohesion than adhesion. They are happy with themselves. वो अपने में खुश है. They don't worry about anything else, right? They don't worry about themselves. They only take care of themselves. अपने में खुश, ठीक है? No intercaste, अपने में कार, right? So cohesion is greater than adhesion in case of non-wetting, whereas in wetting adhesion is more than cohesion. Adhesion, cohesion, we have discussed already. Now the next thing is the contact angle. How to understand or how to make the contact angle. So it is very simple. As you can see here also, everybody, please see, please see, please see. So when you have to make angle, you need two legs, right? Not the legs on which you are standing. The legs means this, angle or angle. We need two legs, right? If we know these two legs, we can easily make the contact angle. You may think like, "Arey sir, it is very simple, sir. Why you are telling?" Because it is very confusing at the same time. Okay, so I'm going to make this super simple for you all. You will never get confused there. So the first leg should be on the solid surface. First leg should be on the solid surface. Please write down these words of mine. It is my kind request as a elder brother if I'm elder than you, and as a younger brother if I'm younger than you. I'm telling you this. Please note this down somewhere. Please remember, one leg should be on the solid surface, but there is a possibility, sir, here or here, toward the liquid. Toward the liquid. One leg on the solid surface toward the liquid. Toward the liquid. Okay. One leg done. Another leg. Another leg on the liquid. On the liquid away from solid. On the liquid away from solid. On the liquid away from solid. Correct? I'll remove this one. This is not required. And this give you the contact angle. This give you the contact angle. Why contact angle is important? Because if the contact angle is less than 90 degree, you are having wetting fluid. But if you are having contact angle greater than 90 degree, you are having a non-wetting fluid. Why it is important, sir? Because always remember, when you are going to study the capillary, some fluids are rising, some fluids are falling. Always remember that the wetting fluid will always rise, whereas the non-wetting fluid will always fall. Clear or not, everyone? Super clear. Any doubt, anybody? So please remember this trick. For making angle, you will be requiring two legs. One leg will be on the solid toward the liquid, and the another leg will be on the liquid away from the solid. Did you note this down? Everybody, Salgar, everyone. Yes, Magnus effect tomorrow we'll see with experiment. Yo. All right, everyone, correct hai. So what I said, I'll just summarize it very quickly for you all. So the first thing I told you is there are two type of fluids. One is the wetting and another is the non-wetting. Wetting fluids are the one in which adhesion is more, means you can have intercaste marriage, but you can't have marriage in your own self. Whereas non-wetting, you should have wedding in your caste only. No intercaste allowed in the non-wetting fluid. Okay guys, first thing. Second thing that I have told you, those fluid in which the contact angle is less than 90 degree, they are the wetting fluids, and those who are having greater than 90 degree, they are the non-wetting fluids. Another thing that I have told you is the wetting fluid will always rise in the capillary, whereas the non-wetting will always fall in the capillary. Any doubt? Anyone? Let me know in the comment box right away, and you can clearly see simple capillary formula, sir. What is the capillary formula?
Sir, ये मैं derive करता हूँ.
Yes, sir.
Okay, let me derive this, guys.
Okay. Two markers, sir.
Two markers.
Use two marker.
Okay. See, everybody, suppose this is the container now, and suppose this is a water molecule. Suppose this is the water molecule, है ना? So, guys, the cohesion force will be coming here. Okay, cohesion. Joshi sir will correct me if I am wrong. Cohesion. This is cohesion. Water and water. It is cohesion, and above is air. So that is adhesion. And in case of water, cohesion is greater than adhesion. Okay, so in case of water, cohesion is greater than adhesion. So earlier the membrane was like this, top surface. It will be stressed below because the below power, the cohesion power is more. The cohesion, so it will be stressed like this. Okay, so surface tension will be coming. Okay, so due to this surface tension, when I put a case nully means capillary tube. So it will rise up with H height. Okay, H height can be different in different diameters. If diameter is more, H will be less. Why that? I will be telling you. Now see, suppose surface tension here is coming sigma, okay, and this angle is theta. So what is the upward force? What is the upward? Sigma is, what is the unit of sigma? Sigma is Newton per meter. Rohan sir and me are just discussing about the dimensions only. That is force per unit length. So total force upward is, what is the circumference there? What is the circumference there? Pi d. Okay, so this is sigma is force per unit length. So total circumference is sigma into pi d. Sigma into total force, because per unit length it is sigma. So total circumference is pi d. So sigma into pi d, and vertical component will be cos theta. If some questions cos theta is not given, you have to take it as 1. So that is the upward force, and downward force will be the weight of this water. Downward force will be the weight of the water is equal to gamma into pi d square by 4 into h. So from d to d will be cancelled, and from here h will be 4 sigma pi to pi will be cancelled, 4 sigma cos theta upon gamma w, that is rho g, into d. So if d is more, h will be less. Okay, because sigma has some power. Suppose it has the power of picking up 3 gram of water. So 3 gram of water will be here more height, and here 3 gram of water will be less height. Okay, got it guys? Oh, sir, water mein adhesion is greater than cohesion or cohesion? Cohesion, I guess.
Adhesion.
Addition.
Adhesion.
Adhesion
In mercury cohesion is more.
No, no,
Water और glass. अगर
Water and
material
glass.
चाहिए ना addition के लिए.
water and glass.
Adhesion.
Addition.
Adhesion will be more. So then, okay, sorry, adhesion will be more. That's why it is going up. Correct? Okay. So got it, guys? Okay, sir.
All right. लो जी. Derivation. बैठे. Right. Okay. So perfect. Okay. Are we good? Okay. Great. So we'll come to the vapor pressure concept, and then we'll talk about compressibility as well. And you were having doubt in absolute, atmospheric, gauge pressure and vacuum pressure, right? How many of you are having doubt? Can you please let me know again, so that I can understand how deeply I have to go in this particular concept. So if a lot of you have the doubts, I'll go just super deep, and I'll let you know in such a way that you never forget this in your entire life. Even if you are sleeping, then if someone wakes you up and asks you, please tell us what is this, all these pressure, you can easily tell them. Please tell me in the comment box by sending a heart sign. If I see a lot of heart sign, I'll just go deeper in this particular concept. Quickly, I have a full blank slide also for you. Quickly tell me. Chaliye, everyone, now, right away. Because this is going to be useful for you, not only this chapter, but it is going to be useful in all the other chapter as well, wherever you will be having a pressure, or maybe in other subjects also, right? Okay, I can see there are a lot of people who are having the doubts. No problem, let's talk about this, and we'll be beginning with our simple salary concept, right? And you will never ever forget this, okay? All right, okay, no problem, let's understand. So let's suppose you all are having a salary of 50,000, or let's take a realistic number. You all are going to get a salary of 1 lakh per month. Okay, how much salary you are having? 1 lakh per month. I'll just write this down here. 1 lakh. कितने zero होता भाई? I don't know. 5 ही होता ना. अभी मेरा है नहीं, मेरे को पता नहीं ना इसलिए. 1 lakh per month you are having a salary. Please understand this, and you will never get the doubt here. Now there is something that you need to make sure. You are going to make sure that in your account, you are always, at any point of time, you are always having 10,000 rupees in your bank account. You can say that is the minimum balance that you have to keep, otherwise you have to pay the fine to the bank. Okay, sir? Now whenever, let's say in January, you get your salary of 1 lakh, right? Or just, I'll just remove this. In January you get your salary. Now what happens whenever your parents ask you what is your salary? Whenever your parents ask you what is your salary, you are going to tell them my salary is 1 lakh. Or how much you are having in your bank account right now. Let's say you are having 0 rupees in your bank account till January. In January you got salary of 1 lakh. Your parent asks you how much is your salary, how much is there in your account. You tell them 1 lakh. But when your friend or girlfriend or boyfriend asks you how much is the balance account in your account, by the way, how much is the balance in your account, you are going to tell them how much? 90,000, because you have to make sure that you always have 10,000 rupees in your bank account. Okay? When your friend, boyfriend, girlfriend ask, you tell them 90,000. Parents ask, you tell them full 1 lakh I am having in my bank account. No problem. Suppose you did 0 expense. And after that in February you get your another salary, and now when your parents will ask Can you please tell me how much amount you are having in your bank account? Please tell me, everybody, in the comment box. Definitely, you are having 2 lakh. You will tell your parents you have 2 lakh rupees in your account. When your friends, boyfriend or girlfriend ask you how much money you are having in your bank account, you are going to tell them 1,90,000, because you have to make sure that you always have 10,000, so you are not telling them the amount. Okay, you are already conserving the 10,000 rupees. Again, you did 0 expense. In the March, another salary drops in, and again your parent asks you how much money you are having in your account. You tell them I have 3 lakh rupees, but when your friend asks, you are going to tell them you have only 2,90,000. Now you tell me, everybody, in any of the case of parent, father, friends, parents, friends, parent, friends, is there any change in your bank balance when you tell either your parents or your friends? It is same only. It is you who is sometime taking the reference from 0. For example, let's take a money line. This is 0. This is 10,000, right? This is 1 lakh. This is 2 lakh. Right. So whenever your parents are asking, what you are doing, you are measuring your salary from 0, correct? 1 lakh, 2 lakh, or maybe 3 lakh, correct? But when your friends are asking you, or your girlfriend is asking you, or your boyfriend is asking you, you are taking, or you are measuring your salary, or basically you are measuring the bank balance from 10,000, 90,000, 1,90,000, 2,90,000. Is it clear or not? Does it make any difference in the money that you are having in your account? Nothing. It is just a way of expressing. It's just a way of expressing, right? Same thing goes for the pressure also. Let's come back to the concept of your pressure here. Please see, everybody, I would really love to teach you this concept so that you never forget this. Okay, so I'll just take this particular line over here. Let's say I give it the name as 0 absolute line. You can call it anything. You want to call it baby, you want to call it Shona, you want to call it Babu, your wish, no problem. Just a name, 0 absolute line. Okay, now it is in my hands. Either I want to represent the pressure from the 0 absolute line, or exactly how I was having in my salary example, I was having reference as 10,000, correct? 10,000, correct? Here we have something called as atmospheric pressure, because it is always there, है ना? Because it is always there. It is always there. I just want you people to just focus on this, please, and then we'll all have jokes and fun. बस एक बार इसको देख लो, please. Right? I have atmospheric. Now let's say I have a pressure. I have a pressure which is more than atmospheric pressure. Let's say PA. Now I can represent this pressure in 2 forms. Now I can represent the same pressure. Nothing will happen to its magnitude. It is up to me how I am measuring it. If I measure it from the 0 absolute line, from here, I will call this as PA absolute. Now this is absolute pressure. But no, if I want to measure this from atmospheric pressure, so it will be called as PA gauge. Sir, PA gauge is equals to P absolute kya? No. Understand. PA absolute is equals to P atmospheric, because this much is PATM, plus PA gauge. just a way of representing whether you want to represent it from atmospheric pressure or zero absolute line. Doesn't make any difference. It won't change its magnitude. Please let me know if this is clear or not. Everybody, right now. Standard atmospheric pressure and local atmospheric pressure. Local atmospheric pressure, see, when I say it's atmospheric pressure, it is basically local only, because if I measure the atmospheric pressure here at my elevation, it will be something else, right? But if I measure it on some other elevation, then it is going to be different, because what is pressure? Rho g h. The value of h, if it varies, the pressure will vary. So wherever you are going to put the barometer, it is going to give you the local atmospheric pressure, right? And standard atmospheric pressure is atmospheric pressure that you take in terms of solving the questions or maybe any problem, right? Please let me know, guys, if this much is clear. Now, for example, if the pressure is less than A, let's say I have a pressure PB. Now, I have two options to represent this particular pressure PB. What are those two options? First option is I can measure it from zero absolute line, so I will call it PB absolute. Or I can also measure it from here, and that will be known as PB vacuum. Sometimes people call it PB negative gauge, right? So can I say that PB or PB absolute, if I want to write, it will be how much? PB absolute will be equals to P ATM, which is this much, P ATM minus PB vacuum. I hope it is crystal clear in front of you. Somebody asked the doubt in the Telegram group that in a manometer, since the manometer is open to atmosphere, why you are not considering atmospheric pressure? Why you are considering atmospheric pressure as zero? Because I was considering the pressure in terms of gauge. Because when I consider the pressure in terms of gauge, can you tell me what is going to be the value of atmospheric pressure, everybody? बताइए. Everyone. When I say in terms of gauge, what is going to be the atmospheric pressure? Nothing. It is here only on this line, right? On this line, which is nothing but the zero. Is it clear, everyone? If you have a doubt, you ask me. If not, send me a heart sign, please. Everybody. Clear hai? Okay. Okay, let's come back to the vapor pressure and cavitation. Now, what is vapor pressure and cavitation? So, please understand, first thing is vapor pressure. Nothing, very simple. You all know when you are going to boil something, it is going to give you vapor, and the pressure which is being acted by the vapor on the surface of the liquid, it is your vapor pressure. Simple concept, nothing else, right? Now, understand the pressure. Please tell me what is the boiling temperature of water. Quickly. At which temperature the water will start boiling? In the comment box right now, everybody. At which temperature the water will start boiling? Please tell me. Everybody, quickly tell me. Quickly tell me, quickly tell me. At which temperature? 0 degrees Celsius. Okay, Carl Desson is saying 100. What 100? What 100? I don't know what 100. Yes, please share the session. Atul has said, everyone. Atul, एक बार please group में भी डाल दीजिएगा Telegram पर. It will be a great gesture from your side as well. Thank you. बेटा atmosphere ये 100 क्या होता है? 100 डिग्री तो लिख दीजिए. Right. Good. The water will boil at 100 degrees Celsius. Wrong. गलत. Absolutely wrong. 0 marks. Negative marking. Minus 0.33 or 0.66. Water will boil at 100 degrees Celsius at room temperature. At room? No, 100 degree at the, not room temperature, by the way. 100 degrees Celsius at what? बेटा room temperature कैसे हो जाएगा? 100 degrees Celsius at room temperature. 100 degrees Celsius itself is a temperature. Tell me, beta, pressure also we have to consider, na? at standard atmospheric pressure, right? Understand, if I do an experiment, and what I do is, if I take water inside this bottle, right, and what I do is, right now, so let's say in my room I have temperature of 27 degrees Celsius, for example. I just close this water bottle and I somehow create vacuum inside this. I have created vacuum inside this water bottle. You know what will happen? The boiling will start. The boiling will start at 27 degrees Celsius only. Okay, so your answer will be wrong when you say 100 degrees Celsius. 100 degrees Celsius at atmospheric pressure. That is the correct thing. Okay, guys? Are you getting me? So please remember, whenever the pressure goes below the vapor pressure of the liquid, the boiling will start. Okay? The boiling will start. Are you getting me? Whenever the pressure will go below the vapor pressure, the boiling will start. So all I have to do, I don't have to increase the temperature in my room. Nope. All I have to do is I have to reduce the pressure inside the bottle and the boiling will start. Okay? Are you getting me? Right? Now, why it is important for us? It is important for us because sometime what happen, you know what is siphon? The pipe which you use to transfer the water from one reservoir to another, right? So what happens sometimes at the siphon, at the summit point of that siphon, like suppose if you are having like this, as you go up, what will happen? Obviously the pressure is getting reduced, right? Pressure will reduce, right? Here you have the least pressure. So here sometime what happen, the pressure goes beyond, or the pressure goes below the vapor pressure of the water, and as soon as it happens, what will happen? The boiling will start. And when the boiling starts, what happen? You can see the bubbles are coming out, and those bubbles, they are not empty. Bubbles are not empty. What does they have inside them? Tell me everybody. Bubbles के अंदर क्या है? The bubbles are having steam. Steam is more dangerous than the fire. If you know this or not, I don't know, but steam is more dangerous than fire, and that steam, those bubbles are going to bombard on your hydraulic machine, and eventually your hydraulic machine will look like this, and this concept is called as cavitation. You can see, this is your machines, how they look like after the bombardment. After the bombardment of those bubbles which are there because of the concept of this particular, you can say the cavitation or the vapor pressure. Did you get the feel? Please tell me. Vapor pressure is more than the pressure in the bottle, then boiling start at 1 degree. Huh? No? 1 degree पे कैसे boiling होगा? If pressure is less than vapor pressure, then it may happen at 1 degree also. Clear, everyone? Please tell me. Clear है बेटा? कोई doubt? Anyone? Feel free to ask. Right? This we will see later. Yeah, pressure variation, super simple. If you want to get the pressure, hydrostatic law, P is equals to rho GH, right? Now here I have a very beautiful question for you. I need your answers right away. ठीक है? Answer देना मुझे फटाफट से. So suppose I have a vessel over here like this, and let's say there is this liquid inside this vessel. There is a liquid inside this vessel. Now understand, please everybody, if I want to know the pressure at h1 height or h1 depth from the surface, can you tell me what is going to be the pressure? Let's say P1. Can you tell me the pressure, everybody? Yes, you can. And that is going to be rho g h1. Density of this liquid, let's say water for the instance, g into h1. That is your pressure at this point. Correct, everybody? Yes. What about the pressure here at h2 depth from the surface? It will be P2 rho g h2. So clearly we can see that my P2 value will be greater than P1, correct or not? Yes. But what if I take another point on the same depth H2? Let's say that is P3. So P3 will also be rho g H2, and clearly P3 will obviously be equals to P2. So all that matters to us is this value of depth. Remember that. Now the question from my side to you is, please tell me, whatever I have said, rho gh1, rho gh2 or rho gh2, whatever, is it a atmospheric, is it a absolute pressure or the gauge pressure? Your concept will be revised very beautifully, okay? Please tell me, will it be, is it absolute pressure or it is the gauge pressure that I have just written over here? And if this is gauge pressure, then what will be the absolute pressure? And if this is absolute pressure, what is going to be the gauge pressure? Right away, please answer. Yes, Atul. Badhiya? Thank you. Chalo. Everyone, quickly tell me. Devlina, okay. Prasad, okay. Bala, very good, okay. Santu, very good, okay. Grishma, great. Lavanya, Anu, very good. Everyone, come on. Answer. Yes, this is definitely the gauge pressure. If I want to see what happens on this surface of the liquid, I am having the pressure which is nothing but P atmosphere. Okay, I am having the pressure as P atmosphere. Correct. All this pressure rho gh1 is because of the water that I'm getting, right? So if I want to write the absolute pressure will be P1 or maybe P2 or maybe P3 plus PATM. This becomes the absolute pressure. Anyone have any doubt? Please let me know. It is my kind request. Anyone have any doubt? Please let me know. It is my kind request. Yes, Ratan, perfectly you have understood. So now those who were saying that they have doubt in the absolute pressure, gauge pressure, vacuum pressure and the atmospheric pressure, is it clear or not? Please tell me that the concept in which you were having the doubts. Hanji Shibi, bilkul, correct, perfectly fine. Here you are having the atmospheric pressure. Anyone have any doubt? It is my kind request to ask you, right? These are all small ninja techniques that you need to know to make your fluid mechanics more interesting and more easy, okay? Hydraulic machine pe ek video. So Deepak, I will make the video, okay? After the gate examination, I will make the video because it is not there in your gate syllabus. So for then, we'll be focusing on hydraulic machine. After that, definitely we'll be making the hydraulic machine video also, okay? Is there anyone who studied that hydraulic machine in the classroom program from me? Koi hai padha hai jo? I taught this to the batch, I guess. I don't remember the batch, which batch it was. But I hope you all have enjoyed. We'll do the same thing again, but this time YouTube. Okay, now pressure measurement. So when you have to measure the pressure, there are various type of devices that you can use. Conventional devices are there, and the most useful one, or you can say the popular one, are the manometers, right? In the manometers, you are having nothing but the glass tubes, and now there are various type of glass tubes. The first one is the very easy to make, and that is the piezometer. Piezometer is simplest, right? Piezometer is simplest. Understand, the only question that you are going to get from this concept of YouTube manometer and all those things is, you need to make the manometric equation. How many of you are having problem in making the manometric equation? Please tell me. The equation that you make from here, PA, then minus we have to do, then plus we have to do, then again we should do minus, or we should put it to the right side of the equals to. Are you having doubt? Please tell me in the comment box right away, please. Everybody. We'll solve the question as well, don't worry, but please tell me if you are having doubt here. This one is your homework question, by the way. I'll be asking you tomorrow, the first thing that I'm going to do at 5 p.m. So I'll give you a ninja technique to make the equation, right? And that is something in which you will never get confused. So that is something where you will definitely get the answer, right? So do we want that? Right? So let's move to that method to get the perfectly correct answer. अपने को चाहिए final answer, right? So let's use this only. I'll just do some labelings for you so that we can understand them very properly. Let's say the pressure here is PA, let's say the pressure here is PB, correct, okay. Let's say the fluid here is A, let's say the fluid here is B, and let's say this manometric fluid is mercury, alright, mercury. So the density of this fluid will be rho A, density of this fluid will be rho B, and let's say they have said this is H1 and this is H. So this is H1 and this is H. Now let's make the manometric equation, and we are going to make this method in such a way that you will never forget this. Yes, we'll be using the ninja technique along with your left and the right side method, and that is the best method that you can use because the possibility of making mistake in this method is 0. Yes, not less, 0. Okay? Anu, I'll give you the time to take the screenshot, don't worry. The first thing that you need to do is, you need to find the datum over here. Why we need datum? I'll tell you. But first, we need to find the datum. Always remember, where the datum will be, datum will always be there at the, tell me, where it will be? It will always be there at a place or at a position where there are two different fluids are meeting. Can you see where two different fluids are meeting? Interface. We call it interface. Can you tell me how many interfaces do you see here? I see two interfaces. I see interface here, I see interface here. Do you see the same or not? Yes, I hope you see this, right? We have two interfaces. Out of these two, which one we have to consider? We'll go for the lower one. We'll go for the lower one. Out of these two, we'll go for the lower one. Please understand, we have to do the same thing. If there is an inverted case, inverted manometer case, the only difference that you are going to see is, instead of the lower one, we will choose the upper one. If you are having inverted case, okay, repeating again, this is a normal case, not inverted. That is why I'm going for the lower interface. But in case of an inverted case, you go for the upper interface, right, sir? Brilliant, you guys are superb. Understand so easily, and that's the best part of this class. Please understand. So now I make this datum here. Why I made datum? To make my calculation easy, because I now have to forget everything which is below this datum. Forget about this whole thing. Do not consider it in the calculation. Why? That is very simple. As you go down, the pressure increases, pressure increases, pressure increases, pressure increases, pressure increases. But as you go up, pressure decreases, pressure decreases, pressure decreases, pressure decreases, pressure decreases. And you all know at same level, I have told you just now also by taking the depth as H2, that at the same level, the pressure is same for the same fluid, beta. This is very important. For the same fluid. Don't think, sir, here. Level same, pressure same. No, that is going to be a very, very big blunder, right? Because when I was telling you rho GH, there was not only H was involved, the density was also involved, correct? Because the density is rho A and the density is rho B. So they can't be equal. But here they can be equal. Here also mercury, same level. But I have told you how to find the datum. Anyone have doubt in the process of finding datum? Is it super easy or not? Only two steps. One, find the interface, choose the lowest interface, and that's your datum. Is it clear, everyone? And you don't have to consider anything below this datum because everything is getting neutralized. Super clear or not? I want a lot of heart signs now. Please, can I have a heart signs? A little bit tired I am now. But please send me a heart sign. I am going to teach you till I am done with this whole thing, right? Doesn't matter how tired I am. Quickly tell me, everyone. The Josh will remain up. And the only fuel that I need is your heart signs. Okay. Perfect. So the first step is super simple. We have got the datum, and next step is simpler than the first one, and that is you just have to separate these two limbs into two parts. What are those two parts? So simply just divide this limb into two parts from the center. Kaat do beech mein se. Now this is my left limb and this is my right limb. All you have to do is write down the equation for left limb, equal it to the right limb. So let's write the equation for left limb first. So here the pressure is PA. So PA. I'm going downward, so pressure will increase. I have to go downward till I reach datum or some interface, right? So let's see. I'm going down, no interface, no datum, no interface, no datum, no interface, no datum, no interface, no datum. Oh, datum I have got. So till here, what is the height? What is this whole depth? H1 plus H. So since we are going downward, that's why plus rho g h. How much is the density? Rho a. So rho g h1 plus h. Done with my equation of the left limb. Simple as that. Now we will make the right limb equation and we will equate them. Let's make the right limb equation, everybody. PB. Okay. Going down, so plus. I'll go down till I reach interface or datum. Coming down, no interface, no datum, no interface, no datum, no interface, no datum, no interface, no datum. Oh, interface is here. So plus till interface, I'll write the equation, which is rho g. How much is the depth? H1 plus. Again, I will start plus because I'm going downwards. Same thing. I have to stop either at interface or at datum. No interface, no datum, no interface, no datum, no interface, no datum. Oh, datum आ गया. Rho of mercury G H. Equation of the right limb. Left limb equals to right limb. You will get your answer. Any one of things will be missed out, so you can find out with the help of others. Is it clear or not? Please tell me, everybody. Super clear or not? Can I have a 200 likes? Please let me know in the comment box right now. कोई doubt है तो doubt पूछना. Same thing we have to do. Only difference that you are going to see in the inverted tube is datum will be on the upper interface, not the lower interface. Great, perfect, easy था ना? मस्त, मजेदार. Very good, great, amazing. This is theoretical. Total pressure, center of pressure. Okay, now let's understand this. Super simple. Total pressure and the center of pressure is super simple. See, though I'm calling them total pressure, that's nothing but that's a pressure force only. Understand how it works out. Very easy, right? Very easy. So, as you know, everyone, just now we were talking about pressure, so you can easily understand it now. So I have a beaker like this, for example. As you can see, I have made a bigger beaker, so things are going to be dangerous now. All right, so we have water inside this, or maybe any fluid. Let's take water for the simplicity. Like this. I know that at this point the pressure will be rho g, whatever the depth, rho g, whatever the depth, rho g, whatever the depth. Suppose I am having a plate inside this. I have a plate inside this beaker. Plate is nothing but this plate. Suppose this plate I am having, but I am looking at this perspective, right? The plate is actually like this, but I am looking at this perspective. We can do this, right? Okay, understand. The pressure here will be how much? Whatever the depth I am having, right? Whatever the depth I am having, rho g, that depth. Here, rho g, whatever the depth, 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 rho g, whatever the depth. If I try to show you with the help of stress distribution diagram or pressure distribution diagram, can I say it will look like this? Because definitely this point and this point are on different elevation. Yes or no, everyone? Very, very easy to feel. बताइए. Easy to feel. Feel or not? First tell me that. That is more important. Right? Okay. Now what I can see is, brother, that the pressure is changing at every point. So there must be a point where the net pressure force must be acting somewhere on this plate because of this pressure distribution, correct? Let's say that pressure force is this. Let's say it is P. That pressure force is this. Let's say this is P. And the point at which this total pressure force is acting is called as center of pressure. Is it clear, everybody? Feel aaya? Did you get this or not? Please tell me. Now there can be a case where you have a plain body or maybe curved body. I have considered here a plain body. It could be a curved body, but I will show you. There is only two things that you need to know here about this total pressure force. If you are having the same thing I have written, whatever I have just said, it is written over here, right? No need to write down anything. You can have a plain body and it can be horizontal, vertical, or maybe inclined. I have took the inclined case, or maybe curved surface. No problem, we'll talk about this. So suppose if you are having a plain body, then the total pressure force is nothing but rho g h bar a. What is h bar? H bar is nothing but it is the vertical depth of CG. Vertical depth of CG, right? Vertical depth of CG. So rho g h bar a, and rest, yes, location of center of pressure. Now this is something important, location of center of pressure, right? How to find out? So it is equals to h bar plus I x sine square theta upon h bar a. Now please understand, what is this theta? Theta is nothing. Suppose if this is the surface and the body is lying like this, body is inclined, correct? Body is inclined. So this angle over here is theta. Can you please tell me, if this body is vertical, what will be the value of theta? What will be the value of theta if the body is vertical? Everybody. Please tell me, what is going to be the value? Force always act perpendicular. Perfect. Yes. Pressure force always act perpendicular. I have done the same thing, I guess, over here also. I can't show you. Tell me. Theta will be 90, right? And what is sine 90? What is sine 90? What is sine 90? Sine 90 is 1. Sine 90 is 1, right? So the formula will become accordingly, sine square theta will become 1, no problem. Perfect. All right. And if the body is horizontal like this, then the value of theta is 0. The whole thing will become 0. H star will become equals to h bar. Correct, sir? You should have no doubt here. Now, different shapes and their value of location of center of pressure. As you can see, it is very easy to find out. Everybody, I have just shown you the formula. You can use that formula to get the value. So h bar, I write this as h bar Cp. It is in my habit. H bar Cp, that is nothing but the position of your center of pressure. If the question comes out, you should know it. And these are the standard cases. If you know these standard cases, you will actually save a lot of time of yours. ठीक है, वहाँ पे क्यों निकालना है? If you can remember it, try to remember it. If in case you are not able to remember it or you are not able to recall them, you can easily find them. Then you know the formula also. H bar Cp equals to sine squared theta h bar a plus h bar. Okay, guys. So let's do this for rectangle, right? The body is vertical, right? And it is exactly the meeting at the surface only. There is no gap, right? So what is going to be the value of Ixx over here? Everyone, please tell me. It will be BD cube by 12. Yes or no? Yes or no? Yes. So Ixx will be BD cube by 12. Sine square theta will be 1 only, no problem. H bar will be how much? H bar will be D by 2. Area will be B into D. Area will be B into D. Put these things inside this formula and the answer that you will get is 2 by 3 D. Right? If you have a doubt, you can check it by yourself for the inverted triangle. Okay? But I have noted down all these standard cases in your PPT so that you don't have to worry about these solutions. Is it clear, everybody? Is it clear, everybody? सब कुछ लिखा है, verify कर लेता हूँ मैं if they are correct. Inverted triangle will be yes, it is D by 2, right? सही है. चलो, now let's talk about the curved surface. Please understand, as you all know, the pressure force will always act perpendicular to the surface. Yes or no? Yes. So let's say I have a surface like this, which is a curved surface, right? So definitely the pressure force must be acting exactly perpendicular to this surface, right or not? Right. But can you see it is inclined? Right or not? It is. So it will be having component, there will be this component, there will be this component, right? Right. Now the thing is, there will be the horizontal component and there will be the vertical component. What is the value of the horizontal component? It is nothing but it is similar to what I have told you earlier, rho g h bar a v. What is v, sir? AV is nothing but it is the projected area. What is the projected area? So projected area is nothing. If you are having a tennis ball, you take the tennis ball like this, you put the torch from here, the shadow, the shape of the shadow is the projected area, right? So the shape of the sphere will be circle. So the shape of the circle, the area of that circle will be the projected area. So the projected area of this surface, this, right? So whereas vertical is nothing but it is rho g v. Right, whatever the volume you are having above this curved surface, that volume you have to take. Now the confusion begins here. Sometime we are taking vertical force in the upward direction, sometime we are taking it in the downward direction. When to take when? Do you have a confusion in this? Then I'll take some time to explain that also. अगर doubt है तो बताइए. If it is clear, then I won't waste your time. When to take upward, when to take downward. If it is clear, it's perfect. But if you have a doubt, please let me know. Okay, suppose there are two type of cases that you need to understand. Okay, horizontal direction, vertical direction. Yes, I have mentioned over here also. Do I have a diagram? No, I don't have. Okay, please see everybody. Yeah. Whether the vertical force must be acting in the downward direction or the upward direction, this you can understand by a very simple concept, and that is you need to see whether the water is supported by the surface. Water, if it is supported by the surface like this, like this is the surface and you are having the water here. Can you see the water is supporting the the surface is supporting the water, right? The surface is supporting the water. This time the force will be acting in the downward direction. Another case can be like this. Another case can be like this. Water is here. Again the same thing, again the same thing. But if there is a case where the body is actually occupying the volume of water, and that is a very, very common case of a cylindrical gate. You must have seen this, right? You must have seen this, that there is a cylindrical gate, the water is filled over here, another water is filled over here. Can you see that the cylinder is taking nothing but the volume of the water? If the cylinder was not here, the water must be up to this level. And as you know, as Archimedes has told us, that if you are going to take the volume of the water will take the revenge, and that revenge is called as buoyant force. What is the magnitude of the buoyant force? Equals to the weight of the displaced fluid. How to get that? Rho g v. What is the vertical force? Rho g v. So that's the same thing. Is it clear? In this case, the vertical force will be acting in the upward direction. Clear? So if the body is taking the volume of the liquid, that time it is going to take the upward direction vertical force. But if the water is supported by the surface, that time it will be downwards. Right? Everyone, is it clear? Perfect. Amazing. You guys are amazing. Great. Moving on to the buoyancy. Oh, Archimedes. So very short story. You all know about the Archimedes. How this buoyancy came into the picture. Let me tell you. Beautiful story. You must have studied this in your school time maybe. I'll just recall it for you very, very quickly. So what happened? Archimedes was a mathematician. He was also a physician. He was also a lot of things. I don't know. Right? हाँ तब का जॉनी सिंस था मतलब ये. तो what used to happen? The king of his empire, what the king has done is the king has given the gold to the person who was taking care of all the jewelry and all those things for the king, and king has told that person that you make me a very good crown of this particular gold. Okay, when that person bring that crown to the king suspected that this person has kept some gold with himself and added some silver in that particular crown. So the king has called Archimedes to find out whether there is any mixing inside this crown or not. Now how to find out whether there was any mixing or not? How to find out if there is any mixing of silver in the gold, because that time there was no machine to find out such things, right? So all Archimedes had to do is Archimedes had to find out the density of that crown, because the density is different for the gold and it is different for the silver, right? How to find the density? Mass upon volume. Mass was very easy to find out that time as well, but how to find out the volume of that crown? How to find out the volume of that crown whose shape is irregular? So that time Archimedes, what he has done is this. He took the beaker, right? It was completely filled with water. Completely filled with water, right? There was another beaker here. Archimedes, what he has done is he dipped that crown inside this water, and when he did that, what happened? The water spilled out. The water spilled out. The water spilled out. Can you tell me what will be the volume of that spilled out water? Everyone, everybody, please tell me. Can you right away tell me what is going to be the volume of this particular water which is coming out? Will it be equal to? Yes, it is going to be equal to the crown. And this is how Archimedes has found out the concept of buoyancy, because what he has done is whatever the volume will be spilled out because of the crown, the water is now going to apply a vertical force on this crown, and what is going to be the magnitude of this vertical force? It is going to be equal to the weight of the displaced volume, and that is nothing but rho GV, density of the water, volume which has spilled out, G you all know. If it is superpower clear, please send me a heart sign. It will be a great gesture from your side. Thank you. Ishan Kishan can teach also. Am I star batsman, furious batsman? Please laugh, everyone. I am in class 10th. Welcome, Durgesh. I hope you are also enjoying the class. I think this is there in your syllabus also, right? In 10th class it was there. 11th में it was there, buoyancy. I guess it was there. I don't know. I was very weak in physics in 11th, also 12th. हाँ जी सर, everybody. थकना नहीं है भाई. Yes, yes. 200 likes we are going to do today. Amazing. Chalo, full power. Now the another thing comes out is the center of buoyancy, and more importantly, what are the effects of disturbances, right? So let's understand the effect of disturbances. Only two things we need to understand: whether the position of center of buoyancy will change or not. It will depend if we are having the case of a floating body or it is a case of a submerged body. So in case of submerged body, everyone please tell me, will it change or not? Right away tell me in the comment box. Submerged body. The position of center of buoyancy, yes or no, change or not? Everybody right away tell me, will it change or not? Sir, वो projection वाला repeat कर दीजिए sir. Projection वाला means curved surface, right? हाँ, तो suppose if I am having, let's take the example of the cylindrical gate like this, right? And I have a water till here. right? I need to get the value of the vertical force here, right, on this particular surface. So the vertical force is what? It is rho g h bar a v, right? Let's say the dia of this gate is 4 and the length of this gate is, let's say, 1 meter. Okay, unity, let's say I'm taking. All right, density you have to take for this liquid. Let's say it is water, so rho w. G, you know what is G. H bar will be nothing but what is the depth of the CG. So whose CG I'm going to consider? The projected area's CG. What is the projected area, or what is the projected shape of a cylinder? Who will tell me? The projected shape of the cylinder will be nothing but it will be a rectangle. Yes? Yes, 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 yes or no? Like this. Correct? Correct. So its CG will be where? Here. What is the depth of this from the free surface? 2 meter. Perfect. H bar is 2 meter. Okay, projected area. How much is going to be the projected area, everybody? The projected area is this. Right? So this is 4 and this is 1. Don't go to the actual numbers. It's okay, right? So the area will be 4 into 1. So that's the projected area. Now is it clear, Shivam? आपको डाउट हो, please ask again. ठीक है? Right? So the area is 4 into 1. That's the projected area. Perfect? No, not 8 meter square. 4 into 1. Not 4 into 2. Correct? The length is 1 meter. The depth is 4 meter. Is it clear? Yes, Anu. It may come in the exam, but hardly they can ask you that. Okay. Clear है ये? ठीक है. So in case of submerged body, the position of the center of buoyancy will not change. It will remain where it is, right? Whereas in case of a floating body, it will change. In case of a floating body, it will change. Center of buoyancy will change its position, right? So now first let's take a understand. Arey yaar, a very simple question it is, right? All you need to do is what? कहाँ गया? All you need to do is what? That weight of your body is equals to the weight of the displaced fluid, right? This is what you have to do. They are saying 93% of iceberg volume is below the seawater, like this. So the 90% iceberg is below the seawater and remaining is the above the seawater. Perfect, no problem, right? So let's say the volume of this whole iceberg is V. So 0.97 is below the surface and how much is remaining? 0.03 will be your at the surface, at the above the seawater surface. What they are asking rest is 7% remaining, right? अच्छा मैंने 97 लिख दिया, sorry. 93 and 0.07. 93. 0.93 is here and 0.07 is above the surface. क्या लिख रहे हैं भैया? 0.7. Right, all you have to do is what is going to be the weight. So what is the weight of the iceberg, everybody? It will be rho of iceberg into G into volume of iceberg, which is V, equals to the weight of the displaced fluid. What is going to be the weight of the displaced fluid? Displaced fluid is nothing but the seawater, right? So it will be density of seawater into G into how much is displaced? 93%. So 0.93 V. Array, what happened? ये तो मुझे नहीं आता सही करना. Yes, I'll keep it. No problem. I'll open it again. Engineer, everything works. You just have to do restart. Right? Hanji. So anything that you need to know here is, this is simple. This you can do, right? See, answer is correct, right? Perfect. Okay, now comes the stability of a submerged body. How to find out the stability? So please remember, whether it depends, they are asking you in the submerged case or the floating case. So submerged case, let's take the submerged case because it is very simple and there is no other concept that you need to understand before it. So the submerged case, if we take the submerged case, what happens, guys? that I'll just make the table over here for the stable, neutral and unstable case. So whenever we are talking about the submerged body, we always compare the center of buoyancy and the center of gravity, right? And that will be, let's say, B and G. B and G, always, right? So if the if I say stable, when the body will be stable, everyone? The body will only be stable if the center of buoyancy is above excuse me, center of gravity, and that is very obvious also. Let's take example. Let's take this bottle, right? If I do like this, right? If I am holding it from here, okay, the bottle's CG is above where I am holding it or below where I am holding it? Just normal guess. Take the normal guess, everyone. Obviously above, right? So if the center of gravity is above this point, what will happen? This will happen, right? The bottle is not stable, it is unstable, right? If the gravity is, center of gravity is above. But if the center of gravity is below, everything is fine for us, right? So if B is above G, stable. In case of neutral, what will happen? Neutral mein B is on G, and here if G is above B. This is simple, no problem. But in case of the submerged to ho gaya, floating body, floating mein things will change. Why? Because in floating we are not only looking at the center of buoyancy and the center of gravity, there is something else called meta center. Now what is meta center? Suppose it is a pendulum, right? It is rotating, it is oscillating about a certain point, yes or no? That point is called as meta center. A ship is going to be doing this motion, rolling. It is rolling about a point, and that point is meta center. A ship is pitching about a particular point, and that point is called as meta center. समझ आया? And what is metacentric height? The distance between the meta center and the center of gravity is your metacentric height. ठीक है? Is it clear, everybody? Sir, for unstable, B below G. मैंने उल्टा लिखा क्या? मैंने क्या लिखा? Let me see. G is above B. सही तो लिखा बेटा? क्या गलत है इसमें? सही तो लिखा है? Did I write something wrong? B is on G. B is above G. Clear, everybody? Right? Okay. So how to actually see this metacentric height and metacenter, all those things. So if the M is above G, सही है ना बेटा? I have not written the below, I considered above. It's okay, right? हाँ जी. In floating case, for stable, let's do one thing. Let's write it for everything, like for both the things, right? And I'm making the table for submerged also for floating. I want from you, when I will turn back and I will face you again, I want to see 200 likes. ठीक है? I'm making the table for you, one table, and it will give you the solution to lot of things, right? So let me just make the table for both the cases, floating also and submerged case also. We are looking at the condition of stable, we are looking at the condition of neutral, and we are looking at the condition of unstable, correct? Yes. Let's consider for two cases, and that is the floating case and the submerged case. So first let's consider the submerged, and then let's consider the floating case. As I have mentioned earlier also, for the submerged case I am more interested in the position of B and G. So if the buoyancy is above G, things are stable for us, correct? But if B is on G, things are neutral, and if B is below G, it is going to be super duper unstable, right? But in case of a floating case, I am not at all interested in the B and G comparison, but I am interested in the comparison of G and metacenter. So if M is above G, it is going to be stable. If M is on G, it is neutral. M is below G, it is going to be unstable. Do we have 200 likes? Then only I'll turn back. Otherwise, I won't. Right? And yes, there is one more thing that we can see here, which is going to define whether it is a stable equilibrium, neutral equilibrium, or the unstable equilibrium. That is nothing but the metacentric height. If the metacentric height mg is positive, then it is stable. If mg is 0, or you can call it gm also. GM actually in engineering language doesn't sounds good. That's why I don't use GM. But okay, good morning भी होता है उससे. GM is positive, it is stable. GM is 0, neutral, and if GM is negative, it is unstable equilibrium. Clear है sir? Everybody? Any doubt? Anyone? Please tell me.
Like नहीं किया बट दोस्तों का.
Like नहीं किया, ये तो भाई गलत हो गया. धोखा हो गया मेरे साथ सर. Everybody, please welcome. Chandan sir is here in the class. Everybody, come on. Full power, heart sign, welcome.
Hello everyone, how are you? कैसे हैं आप लोग दोस्तों? How are you everyone?
Quickly, heart signs.
So hope you are enjoying the fluid mechanics. Even I am also understanding that B is above the G. The system is stable and the neutral on the G. But the system is?
This is two cases, sir. या तो body will be submerged, या body will be floating.
Yes.
Right?
So
Very simple.
In a very interesting manner, you guys are basically understanding the fluid mechanics by your ninja sir. So everyone, how are you? And definitely you guys are basically going to rock the paper because देखो, everybody is basically preparing. But the gate is basically not all about how the people are basically preparing. The gate is basically all about whether you are serious or you have a passion for those particular exam or not. And from the morning itself, you are sitting into the, you can say that into the mobile, or you are watching the mobile in the continuous manner. Itself indicate that all of you are basically the very much serious regarding to the gate paper. And so this is my best wishes, guys. You are going to rock the paper, and definitely in this gate 2022.
Yes.
You guys are basically going to get a very good rank, and you will going to be selected into the PSU. That is my best wishes to you, everyone.
Amazing, amazing. So देखो, not only from civil.
सर इतना पेशेंस किसी में होता नहीं कि इतने देर बैठ मतलब कैटरीना के डांस कर देगी ना, तब भी किसी में इतनी हिम्मत नहीं कि 8 घंटे कैटरीना का डांस ही देख सके. और वो फ्लूइड मैकेनिक्स हमारे जैसे गंदे गंदे शक्ल वाले लोगों को इतनी देर तक बैठ के देखते हैं. That will itself indicate that you guys are superb and amazing guys, right? So thank you very much, all the very best guys. Thank you very much.
चल बढ़िया बढ़िया. So you have everyone with you, not only from civil. You are getting your support from all other branches also. समझ रहे हो और क्या चाहिए, right? So if you are ever feel like you are not confident enough, have faith in us, have confidence in us, because we have full confidence in you. From 10:30 you are watching the marathon class. First you started watching class of Abhinav sir, and then you took break of 1 to 5, and then again we are here. Continuously they are here, sir. Continuously.
They are going to definitely, that is the amazing. Right?
Continuously they are there, and that is the best thing that can we can actually see.
MSQ session, guys.
MSQ session.
One more thing, guys. In this year also, we already know that IIT announced the one thing, that is maybe the MSQ question will come. So how we are going to prepare the MSQ question? There will be the one session.
Right.
Today and tonight at 9 p.m. There will be the one session for the regarding to the MSQ on the Hindi channel. So you can say that was invited on those particular session also, right?
Hindi
link
channel.
will be shared. Link will be shared.
Link will be shared.
Every Telegram channel. You have to join it, where we'll discuss about how we have to deal the MSQ question, how we have to attempt those type of question, how the conceptually should be strong for those attempting those particular questions, and how many expectation is there, how many question we can expect in this year regarding to the MSQ.
Right.
That's what also we are going to cover, right? So
Yeah.
guys, MSQ. Yes, and how the BYJU'S exam prep is going to help you. That is also we are going to discuss.
Right. So Abhinav sir and Chandan sir will be here in front of you exactly at 9 p.m. tonight only. The link will be shared already in the groups, and again we will be shared. Okay.
Yes.
All right.
So thank you guys. Thank you very much.
Thank you so much, sir. Okay. Okay. So we were here at metacenter and the metacentric height. So again, whatever I have just said, see all the love that we all get. I also get from such a senior faculty members. Abhinav sir is also senior faculty, but now I am so friendly with him that we have become brothers, right? And a few like minutes back, Sanjay Rathi sir, he was also here, one of the greatest faculty of his subject in India, literally, right? So yes, amazing, brilliant, full josh, full high ekdam, right? Acha, so we were talking about this one thing, that how to find out the value of metacentric height, है ना? राइट, इस फ्रेंड को समोसा खिलाने का वादा करके हॉटस्पॉट ऑन करवाया है यार. I'll bear the expense. I'll bear the expense. Please let me know. Okay. Please let me know. I'll bear the expense of the samosa. But yes, definitely, I hats off to the dedication that you people are having. Okay. Chaliye. So let's find out the value of the formula for your metacentric height. Okay, and this is the last thing that we are going to do for today, and then you can have a break because again we are meeting. I'll also jump into the session of Chandan sir and Abhinav sir. Okay, I also have few points and I'll tell you that time only, right? Chalo. So it is how much? It is I minimum upon volume displaced. This is the same volume that you are displacing whenever there is a body in the liquid, right? So what, there must be something displacement also, minus Bg. Bg is nothing, it is the distance between the center of buoyancy and the center of gravity, correct? Okay, volume displaced, as you all know. What is this I minimum? For which shape we have to take the I minimum? Understand, this is very beautiful concept. I really love this concept and that is why I am teaching you also. Okay, please understand. Suppose if I am having a cylindrical body, right, and the cylindrical body is floating. We are only talking about floating, right? We are only talking about floating because then only the metacenter will come into the picture. Will you get metacenter? Will you get metacenter in case of? Will you get metacenter in case of submerged body? No, you won't. Only floating case mein you will be having it. Correct, sir? Okay. So suppose the water is up to this level. Now understand. Suppose the water has decided to become ninja like me, and it is going to cut this cylinder. Can you tell me what shape you are going to see from top? Circle, right? Circle. कल नहीं, आज ही बताएंगे. तो you will see circle. You have to take the value of I for this shape of a circle. Similarly, if you are having a cone like this, again the water will cut. What you will see from top? Maybe elliptical or maybe circle, whatever the shape you are having. Suppose you are having a cuboid like this. Right? And the water cuts it down. What you will see? Square. You have to take the I of shape square. Simple. Right? Simple. Okay, what if you get a rectangle? In case of rectangle, please remember, see, in case of circle, in case of square, doesn't matter if you take moment of inertia corresponding to this axis or about this axis, it will be same for square also, for circle also. But for rectangle, it will be different for this and different for this, correct? So I have to choose the minimum of these two. दोनों में से जो भी minimum होगा, that I have to consider in case of rectangle, because moment of inertia will be different about this axis and about this axis. So the minimum one I am going to consider. Why minimum I have to consider? I am going to start tomorrow's session with the explanation of that particular concept. Let's close the session now. Here only. Please send your love with the heart sign and also by hitting the like button to make it 200 likes before we close this session. And please ask if you have any kind of a doubt that you want to ask me. I'm there for you, right? And guys, again I'm telling you, if you get any type of problem, if you need any kind of guidance, do not worry and do not think that you are alone. I'm always there with you. You can just hop into this Telegram group also. I'll send the PDF in this Telegram group. Here it is. So you can join this Telegram group and ask whatever doubts you are having. Okay, thank you Ishan Kishan, thank you so much Durgesh. Okay, what if I tell you he is my real brother? All right, clear, amazing, great. Chalo, thank you so much for being here everybody, and I'll see you tomorrow with the same energy, same enthusiasm, but different concept, different topic. Till then, you have to do two things for me. First, please take care of yourself, and second, please take care of your family. Thank you so much for being here. My name is Joshit Singh, and I will see you in the next session. Bye bye, take care.